Hi everyone, I'm teacher Felicia. Yeah, so you can call me Miss Felicia. So I will be teaching you Sec 3 IP Physics for today. So for the lesson material, for the mock exam at the back, question number 14, there is an error. Most of the copies we have helped you to cancel it already. So maybe you just double check your copy. If it is not cancelled, then can you amend it? Just cancel the word rate off. Okay, just small errors. And you are required to complete the mock exam paper before coming to class. Yeah, so if you haven't, then you try your best and multitask and do as fast as you can. Because later I'll be going through the answer for the mock exam paper. Okay, so then yeah, so let me just give you a little bit introduction about myself in case you never like see me before. So this is my name. You can call me Miss So I mainly specialize in teaching IP sciences. So I teach from Sec 1 till Sec 4. Yeah, so for upper Sec I tend to teach chemistry and physics. Yeah, so before teaching at Overmark, I previously actually taught at the Learning Lab for 7 years. And before the Learning Lab, I also taught at another tuition center called Wisland. And I also did like quite a lot of really teaching among like the different MOE schools. Yeah, so far these are my track records. So my student crowd is usually mostly is from NYGH, but I also do have HDI, RI, and RGS students also. Yeah, so I have like a class of like RGS students also. Yep. So just to share a little bit about myself. Yep. So I'm actually a board game lover. So I like board games so much that at home I buy like really board games, a lot of board games. I even buy like expansion pack and stuff. Then I'm spending like hundreds of dollars kind. Yeah. So I don't know whether y'all did notice that like if you were to be like going to the toilet, oh yeah, on the way to the toilet there is actually a snack bar. There's actually free snacks over there. So it's a free snack bar. So if you want, you can go and get the snacks, then you can eat during lesson time. Yeah, so above the snack bar, there is actually like a lot of games. So all those is actually I buy one. Yeah, so I really like board game that I even like bring games into my lesson. Yeah, so I will play with my student this thing called the wet heads. Yeah, so wet heads is like maybe for certain chapters that like you really need to study. Like maybe you need to remember what's the formula for maybe like what sulfates, carbonate and stuff, or like different content that yeah, it's a must to remember because that's the foundation. Then usually I'll test my student on the next lesson. Then those who didn't study, then answer wrongly, they need to pull the stick. So it's like out of all the stick, only one stick you pull will get wet lah. So really like it's like a punishment lor. If you never study, then yeah, you'll get wet. But I don't put that much water lah, because you still need to go home. Yeah, so that's wet heads that I played with my students. Then I also played like this card game called like Ions, where it's the formation of all the chemical formula. Yeah. And for me, I always believe in a rewarding system. Yeah, so I'll always reward my students when they do well. Yeah, so this is actually like my Sec 2 Nanyang class, yeah, where the recent WA3, like the whole class, like of 14 students, they all got A1. Yeah, so then it's like so well done, right? So of course need to reward. Yeah, so then I let them choose on. Then they say that they want to choose Wingstop. Yeah, so I ordered like $100 of like Wingstop for them. Yeah, then yeah, this is a photo. Then sometimes also like I will give like soft toy as reward. Yeah, so that's why they are like posting with soft toy and bubble tea. Yeah, so bubble tea as reward, pizza, yeah, as well as like acai affair. Yeah, so if you're a student of Overmark, actually we have like acai student affair. Yeah, sorry, what am I talking about? Acai affair student discount. Yeah, from downstairs as well as Singapore wide if you are Overmark students. Yeah, so yeah, these are the cups of the acai that they are holding. Yep. So then, yeah, for me is that I find that like for a subject that you want to do well in, you must first have at least, like the interest in it, ma. Because if like you don't like the subject, how are you going to do well? So usually for me is I will try to incorporate like practical lessons. Yeah. So for Overmark, we also do prepare your if you have like practical exam coming up. Yeah. So done for myself. So maybe just to share a little bit with you about Overmark in case you never heard of this brand before. Yeah, so for Overmark, we are actually a very well established tuition center. We have various centers across island wide, as you can see. Yeah, so we have 7 branches across Singapore, and our student count is exceeding 1,000 students. Yeah, and you can actually reach us out on the various platforms. Yeah, so if you're interested to attend such free revision lesson in future again, you just follow Overmark on like IG, Telegram channels, or TikTok. Yeah, then that's where we will actually announce on the free lessons. Yeah, so I think maybe some of y'all might have attended my previous session, which was like the WA2 revision. Yeah, so we always have like here and there we will organize like free lessons or maybe like free like seminar or maybe like free materials that we'll distribute. Yeah, so you just follow us lah, so that you can keep updated to the news. So this is so far the records from Overmark. Yep. So 70% of students achieve distinction, meaning like A1, A2 or like 3.6, 4.0. Yep. And that our teachers here are all university graduates. So well assured that you are in good hands. Yep, and for Overmark, we are also featured in various newspaper. Yeah, so we were featured like in Today newspaper, Straits Times, various newspaper, including like I think there was like an Indian newspaper, Chinese newspaper. We were also featured also. Yeah, so we are actually a tuition center that first do large scale mock exam. As you can see, like there are really a lot of students. Yeah, because like right now nowadays like MOE remove like mid-year exam, right? So it's like how are you sure that like you are well prepared for an end of year exam, yeah, without any like practice in between. Yeah, so that's why we actually organize like mock exam, and there are really a lot of people that actually sign up. As you can see, like there are like hundreds of people that actually sign up for it. Yeah. Yep. So if you were to join us as like a student, I think some of you are our overmark students, you all know lah. So these are the things that we will provide you. Yeah, we'll definitely equip you with as much learning resources as you need to well prepare you for the exams. Yeah, so like during the practical period, then we will also like do like practical experiments. Yeah. Then yep, so these are the materials that we'll provide. Yeah, then I think mainly that's about it. So let's start off with our revision now. So just to share with you an overview of the lesson for today, I will first go through I will only select 3 topics lah. So we'll go through 3 topic notes, which would be dynamics, turning effects, and lenses. Then after that, we'll go through the mock exam paper, which is found at the back. Yeah, so we'll go through the correction. And no worries, I will be providing you the answer key at the end of the lesson. So maybe like some of you who didn't do the mock exam paper, then like wow, a lot of things to write, right? So no worries, I'll give you the answer key. So if you can't copy finish everything, you can still refer to the answer key and slowly note down your correction at your own time at home. Yeah, so without further ado, let's begin. So just to confirm one last time, everyone has the lesson material needed for today, right? Because I'll be using the lesson material. So for online attendees also have, right? Okay, so let's start now with the first chapter. So we start off with kinematics. So the page number that I'm at can be seen on the right side of the screen. So can you all flip to page 4 now? Okay, so for the topic on kinematics, I think you all should know, right? There are all these quantities that you need to know what each of them represent. This one, I think no problem. So this one, I'll leave it to you to study on your own. I'll go through the more confusing stuff, like the calculation formula as well as the graphs. Okay, so for the calculation formula, take note that whenever they mention about average, right, you need to make sure that you include the total distance and total time. Meaning, if the question say that like the person is like, take a break, resting, remember to include the rest time also. So just to let you know, my lesson style is I'll write a lot of annotations and highlight things. So can you all follow and like note it down? Follow and copy it down, please. Thank you. Okay, then next is the formula for acceleration. So need to know that V, this one you all should know by now. V is like final velocity, U is initial velocity. Then of course physics must know the units, right? So if units is wrong, then it's incorrect. So for acceleration, the unit is ms minus 2. So this equation, you can actually rearrange it to become V equals to U plus AT. Yeah. So these 4 over here, these 4 would be under equations of motion. So most IP schools do cover equation of motion. If your school don't cover, then this 4 you can ignore it lah. Yeah, so this is actually the IP section where usually express school students they don't learn because it's brought down from A levels. Yep. So the 4 equation of motions, when do you use which? You look at the question to see what quantity is given to you, then you use the appropriate one. Okay, then moving on to the next part, done with all the annotations, right? Okay, next part over here, interpreting of graph. Okay, so you see, for kinematics, the graph got so many shape and all, right? So it's almost impossible to memorize every single graph, correct? How can you memorize, okay, maybe this distance time graph, how to become a speed time graph? Or maybe this velocity time graph, become what shape acceleration time graph? It's impossible to memorize. So how do you like go about remembering like know how to convert? So the method would be you follow these guidelines over here. Once you can remember all this here, right, then no problem already. You will be able to answer all graph questions. Okay, so first, this one, I think you all should know, which is displacement time graph. When you look at its gradient, it will tell you the velocity. Then for velocity time graph, when you look at its gradient, it will tell you the acceleration. Then for acceleration time graph, when you look at the area under graph, it will tell you the velocity. Then velocity time graph, when you look at the area under graph, it will tell you the displacement. This one quite easy lah. I will go through mainly this part here. So this is actually my teaching technique. So this is how I teach my students to be easier to be able to remember it. Okay, so if you were to be given a displacement time graph, first you check, is the gradient positive or negative first? So in math, you all learned before, right? If it's upward sloping, that would be positive gradient, correct? Then if it's horizontal, what kind of gradient do we describe this? Is it zero or is it constant gradient? Do you all know? Horizontal line. What type of gradient is this? People, I'm asking a question ending with question mark, so I need a response. So how would you describe the horizontal line? Is it constant or zero? You definitely learned it in math before. You also learned kinematics in school before, right? So what is it? What is it? A lot of uncertainty. The answer is zero. Okay. So it is the value is constant. But when you look at gradient is zero. Okay. Then downward sloping line is negative gradient. Okay. Okay, so if you want to say constant gradient, it will be like this straight line. So if it's a straight line up or straight line down, that is called constant gradient. Because constant means the slantness remain the same. But once your slantness become horizontal, right, that is zero gradient. So don't get confused. Yeah, so can you follow and copy this in so that you know what it means by positive and negative gradient? Copy it down. Okay, so in a displacement time graph, if the line is going up, it just means that it is moving forward, which makes sense, right? Because you are getting like further and further away from displacement zero, further and further away from the start line. Then if it's negative gradient, that means like coming down, that means like you are either U-turning back or else you are going further and further from the start line. Next, if your graph is above the x-axis, that means you're at the positive side. What does it mean by positive side? Meaning, for example, if I say that my start point is here, my end point is here, if the graph is above the x-axis, that means my vehicle, right, it would be at here. It would be between the start and end point, which we call it as positive side. So positive side means it's on the right side of the start line. Then if it's on the left side of the start line, I would term it as at the negative side. So that means if your graph goes below the x-axis, that means your car, it would be at the bottom. Let me do it in different color. Yeah, so it will be like over here. So you need to know the location of your object also. Okay, so let me show you some examples to interpret. Okay, so if we were to, maybe let's try and draw out some graph. You try to draw a bit smaller, okay, because I'm going to draw like a few graph. Okay, so you all know, right, displacement is called letter S. S is not speed, okay, S is displacement. So with a displacement time graph of, maybe I draw the curve like that. Okay, so in this case, how would we describe the motion of the vehicle? So we would say that this is actually, can you see that the graph is actually a positive gradient? That means this vehicle is moving forward. Okay, so I'll write down at the side. Can you follow and copy down too? So you need to know that the vehicle is moving forward. And next is how is the, when it's moving, how is the speed? So remember, in a displacement time graph, we can look at its gradient to know the velocity. So for the gradient over here, how will we describe the gradient over here? Is it increasing or decreasing gradient? Increasing gradient, no. So this is increasing displacement. Okay, right down here. Increasing displacement because you get further and further from the start line. But the velocity is decreasing. Why? Because if you look at the gradient, at the start, very steep, right? But towards the end, very gentle. So your gradient has decreased in steepness. That's why it's called decreasing velocity. And now that we are talking about velocity, you need to know that the velocity is going forward and it's getting further and further away. Yeah, so this is how you interpret for the displacement time graph. Then usually, for this topic, they always like to test you on how do you convert between the different graphs, right? So from this displacement time graph, do you know how to convert to a velocity time graph? Okay, come, I give you some time. You give it a try. Can you draw out what is the corresponding velocity time graph for this diagram here? Yep, you draw it out. For Lucas, you're asking how to change from acceleration to displacement time graph. You can't do an immediate change. You have to convert it to a velocity time graph first. Then from velocity time graph, you then continue to change to displacement time graph. Okay, so should be done drawing by now. So how do you all draw the velocity time graph? Can you use like your finger to like point to me? How do you all draw it? No, it's not supposed to go down. Wait, sorry, yeah, correct. It's supposed to go down. But the going down, is it a straight line or is it a curved line? Can tell? Curve or straight? The answer is straight line. Okay, so no worries. If you get it wrong, good that you all come today. Yeah, so I'm going to explain to you now. Why is it a straight line? The reason is because we said that the velocity decreases. Okay, so if the velocity decrease, can you see it's from this number, you decrease, come down, correct? So you decrease, come down. But the thing is that over here, if you want to know the curvature, isn't the curvature the gradient? What does the gradient of the velocity time graph tell you? Let's check. Gradient of velocity time graph tells you the acceleration. Over here, did I mention anything about the acceleration? Is it an increasing, decreasing, or constant acceleration? I didn't tell you what. Then how you know it's a curved line? So it's not possible to tell. So not possible to tell, you just draw it as a straight line. Okay? So that's why you should draw it as a straight line now. Because now if you work backwards, right, then it will make sense really. Because for the velocity time graph, if you were to look at the area under graph, you realize at the start, wow, the area under graph is huge. But towards the back, the increase in area under graph keep getting lesser. So that's why it keep getting lesser. That's why it becomes a plateau eventually. Okay? Yeah, like that. Okay, so so that's how you interpret it. Let me show you another graph. So this is like above the x-axis. Let's draw another version. So if I were to have a displacement time graph underneath. Okay, so let's draw another displacement time graph. And this time, instead of curve upwards, maybe I come downwards. And then I curve, let's see, I curve opposite. Okay, curve like that. Okay, then now, likewise, how do we interpret this graph? So you follow the legend over here.
I don't know.
Okay, so for this part over here, if we were to look at the movement, let's see, is it positive or negative gradient? So this line, is it positive or negative gradient? Look over here. Is it positive or negative? Hello class, I'm asking you a question. Is this a positive or negative gradient? Look over here. What kind of gradient? No, you just look at like that. Just like that. Don't overthink. I think you overthink. So just look at this part over here. Is it positive or negative gradient, class? Negative, right? Because you see it's coming down, right? Coming down. Coming down means negative, okay? So let's take note first. Negative gradient means it is reversing. Okay, so right now here it is reversing. It means moving backwards, okay? Reversing. Going in the opposite direction. Okay, then next is let's check. It is below the x-axis, right? So it's below the x-axis means it's at the negative side. Write down. Are you copying? So that means it is like before the start line. So that's what they're trying to say. Because at 0 meter, you are at the start line, correct? But if it's at negative, means you are before the start line. So that means in this case, the car is reversing further and further away from the start line. Can visualize it? Then you are reversing further and further away from the start line. Okay, then now your turn. Can you draw a VT graph? Oops, I know space. I'm going to squeeze it here. Okay, so can you draw out the corresponding velocity time graph? How to draw then? You give it a try first. It's okay to get it wrong, because you just try now, then I will go through the answer soon. How to convert to a VT graph? Okay, so I shall review the answer. So, okay, or maybe instead of me reviewing the answer, can you all like point using your finger? How do you all draw for this? Okay, can. Then what? Any other answer? So the rest of you like not sure, is it? Okay, so the correct answer is this. So yep, you are correct. Good. So why is the answer like this? The reason is because we see that the velocity, remember, to know the velocity, you look at the gradient of the displacement time graph, right? So when you look at the gradient, how is the gradient? The gradient is getting gentler and gentler, right? At the start, very steep. Towards the back is gentler. So that means the gradient decreases, and gradient is the velocity. So the velocity decreases. Like that is decrease, like surprise. How long go up is decrease, because you need to take note that math and science is opposite. In math, okay, for example, I put a fake number here. Okay, maybe this is like -5, for example. In math, we will say that -5 is smaller than 0. Do you agree? But then in physics, right, it's opposite. -5 is bigger than 0. Why? The reason is because the negative sign over here refers to direction, because this is a vector quantity. You all know, right? Velocity is a vector quantity. So the negative just saying that, okay, I'm reversing. But what's my speed? I'm speed of 5. Isn't speed of 5 moving compared to 0? Isn't 0 at rest? So which one is moving at a faster speed? Is it moving or at rest? Isn't moving at a higher speed than at rest? Correct? So that's why -5 is a bigger speed than 0. So take note that math and physics is opposite. Okay? Because physics, our negative is not part of the number. Our negative is just the direction. Okay, so then in this case, that's why from -5 to 0, it is actually becoming smaller. That's why smaller should go to 0 to come to a rest. Yeah, so this is how you draw it. Yeah, so generally you just need to follow this guideline, then you will know how to go about like in its like direction and motion, or plus the gradient. So just combine all of them together. Okay, so then moving on to the second column. So second column would be velocity time graph. So for velocity time graph, when you look at its gradient, it will tell you the acceleration. So you see, it represents different thing. Earlier on, the gradient tells you the direction. But now the gradient tells you the acceleration, because the gradient represents something else now. Yep, so if it's positive gradient, means acceleration. Negative gradient means deceleration. And take note, okay, that whenever it's deceleration, it can mean two ways. So this, okay, I'm going to write it over here. Can you follow me and copy it down? Deceleration can be interpreted two ways. The first way is you can say that you decelerate. Isn't deceleration means that it is a negative acceleration? Okay, so wait, let me just add on a little bit more. Yeah, acceleration is negative acceleration. This one you all know, right, from school. Okay, so one way to interpret is I decelerate. Decelerate means like you step the brake of the vehicle, right? That means you slow down in the positive direction. That means I'm still driving forward, like the car, driving forward, but I press the brake. Another way to interpret it is because deceleration is negative acceleration. That means I can be accelerating. So that means I can be speeding up. I'm accelerating. But then it is in the negative direction. Yeah, so that means the negative here applies to the direction itself. So take note, okay, that deceleration can mean speeding up or slowing down. So the direction matters. Yeah. Okay, so let me explain a little bit more to you. Yep, so over here, negative gradient is deceleration. Later I show you scenario where when is it like slowing down, when is it speeding up for negative acceleration. Okay, so next is you have to check the graph. Is it above the x-axis or below the x-axis? If it's above the x-axis, that means your v value here, isn't it positive? Because this is a vt graph, vt graph above x-axis is positive speed. Positive means I'm driving forward. But then if it's below the x-axis, isn't it a negative velocity? Then negative velocity means I'm reversing. That's why I wrote over here. Okay, so now let's try to interpret the graphs again. Okay, so maybe because of my limited space, I shall just continue on to add on. So maybe from here, we convert it to an acceleration time graph. That's why I told you to draw the graph smaller because I'm going to cramp a lot of things. Okay, so let's interpret this velocity time graph first so that we can draw out the acceleration time graph accurately. So for this case, let's take a look. Is this positive or negative gradient over here? Negative, correct, because it's coming down. So just remember, this one is always telling you about the gradient. You can write it clearly, like if you're not sure. So this line over here, the plus 0 minus is for gradient. So coming down is negative. So I put a negative sign over here. You can see my negative sign here? So I'm trying to say that the acceleration is negative. So if acceleration is negative, remember I told you, you can interpret it two ways. So what you need to do is, you have to check. In this case, how is our velocity? We mentioned that the velocity is slowing down, correct? Because from God speed become at rest. So if this is slowing down, that means this negative acceleration is actually this, slowing down in the positive direction. Because remember, above the x-axis, I'm moving forward. That means the positive direction. So this time around, the negative acceleration is the left side. So I'm going to write it in, slowing down in, oops, sorry, I tried to squeeze it in, negative direction. Can you see my words? Slowing down in negative direction. Can you follow and copy it down too? So you see, it is coming to a stop. Wait. Give me a while, give me a while. Wait. This one is sorry. Why am I writing sorry. I copied wrongly. It's slowing down in positive direction, right? Sorry. I read wrongly. I see. Let me change it. Right, I said that must copy the left side, right? I don't know why I copy until the word is wrong. Negative. What is it? You're writing the same mistake. I don't know what am I doing. Sorry. It should be positive direction. I see. Okay, so just copy the left side word. Okay, so if you cannot see my words here, cause too cluttered, you just copy the left side word. Can slow down in the positive direction. Cause positive velocity means you are moving forward. Okay, then next would be that we will draw the acceleration time graph. So now we know that you are slowing down, and this is a negative acceleration, means I must draw in the negative region, right? So now can you give it a try? How would you draw this graph when I give you the hints already? The acceleration is negative. That means you need to draw in the negative region. So how are you going to draw? So can you convert this VT graph to acceleration time graph now? So can you convert it now? Okay, so done drawing. So what's your answer? So can you use your fingers to like point to me, like how are you going to draw? How to draw the AT graph? How to draw? If you all are not answering, then maybe for today's lesson, we take turn. Thank you very much. Okay, so later I will take turn. I'll call everybody, then everybody take turn to answer one question each. Yep, so the answer is horizontal line. Why? Because if you look at the gradient, you see that at the start and at the end is the same slantness. So it is constant gradient, right? So that's why if the gradient is constant, that means it is constant at this particular value of 10. So, okay, I try to squeeze it in a bit, no space. So it's negative plus constant. Can you see the steepness at the start and at the end is the same slantness. So constant gradient. Remember I told you horizontal line is zero gradient. Constant steepness is constant gradient. Yeah, so don't get confused between constant versus zero. Okay, then now let's give it a try for this one also. Can you now, without my hint, can you now convert it to an acceleration time graph? Sorry, I know space, I'm going to like squeeze it on top. Yep, so can you draw in the acceleration time graph now? How would you draw it? Draw now. Oh, I realized that actually this one, sorry. Can we don't draw the acceleration time graph? Because I realized this one is beyond syllabus. Because this one end up will have a double negative effect. Yeah, so this one, this one we will skip it. It won't be tested. Yeah, this one double negative. Double negative means that the acceleration is negative, and then the velocity also negative. Then both negative, your acceleration became positive. Yeah. So not tested. Yeah. So don't need to know how to convert. They won't ask you to convert this. Okay, so done for velocity time graph. Then next would be acceleration time graph. So you go by, if your AT graph, your A is above the x-axis, that means your A value is positive, right? That means you are accelerating. But then if your line is below, that is deceleration because it's negative acceleration. Yep, that's why it's below. Then don't need to read gradient anymore. Because you see from here, there isn't any more arrow that says gradient to tell you the next quantity. Yeah, so don't need to read the gradient, just directly interpret it will do. Okay? So now let's okay, to make sure that you fully understand this section over here, I shall test you a little bit more, because when I ask you all how to draw, you all everybody like just sit there and wait for me for the answer, like not sure. Let's practice a few more graph conversion before we start. I believe the last page is a blank page. Can you all flip to the end of the booklet? Is the last page empty page? Okay, come, let's use the last page and the very back of the booklet. Okay, so I'm going to give you the various velocity time graph. You have me to convert forward and backwards. That means you convert the displacement time graph and you convert to the acceleration time graph. Okay, so I'm going to draw it in this space over here. Okay, so if my velocity time graph, let me think. If I want to draw it as like that, okay, can you convert to the displacement time graph and acceleration time graph? You do it now? Sorry. Can I change my question? I realized my question a bit like not quite feasible. Okay, like that. Sorry. I make it easier, straight line. Okay, like that. Sorry. Yep, so we change to this. We convert to displacement time and acceleration time. Okay, so I shall ask you all individually for the answer, okay? Because every time I ask question, then you all don't want to respond. Okay, so I start from the back instead. Okay, so I start from Aries first. Okay, so for Aries, for this VT graph, okay, we do acceleration time graph first. So how would you convert to acceleration time graph? Can you use your finger to point to me like how you're going to draw? Horizontal line below the x-axis. Like that, is it? So how about the rest of you? What do you all think? Do you all agree with this answer? Yes or no? Then how about the rest of you? Any idea? Still so lost. Okay, so the correct answer is, yeah, this is correct. Very good. Yeah, so Aries got it right. Yeah, why? Okay, so how you interpret it? You look at the gradient, right? Because gradient of velocity time graph give you the acceleration. And how would you describe the gradient? This is a positive or negative gradient? What kind of gradient is this? Positive or negative? Negative, right? And then next is, you look at the steepness. Is the steepness like increasing, decreasing, or constant? Constant, correct. So that's why in this case, it's constant negative or there. You see that this value is a negative value, is constant at this negative value. Okay? Okay, then now let's go this way. So I continue on to Nadia. So for Nadia, how would you draw the displacement time graph for this? Straight or curve? Curve thing. How you curving? Like that or like that? Oh, like that. Okay. Okay, so the rest of the class, what do you all think? Do you all agree with this answer? So how? Agree or disagree? So no idea, is it? Okay, the answer is incorrect. The correct answer would be at the bottom. Yeah, so it should be like that. Why? Okay, at least the curvature is correct, just that it's at the wrong side of the graph. How to interpret? Okay, so remember that gradient of a displacement time graph give you the what thing? Gradient give you the displacement time graph. Gradient gives you the, if you're not sure, can you check your notes? I mentioned just now, right? Displacement time graph, gradient tells you the velocity. Yeah. So then in this case, how is the velocity over here? Let's see. The velocity, can you see it's from 0 to super negative? Then remember I told you math and science is opposite. So in this case, is your velocity increasing or decreasing? Okay, then I move on to Gerald. So what do you think is the answer? Is the velocity increasing or decreasing? Remember the math and science thing? Increase, correct. Because over here, do you realize you are at rest? Then here you are moving, right? So aren't you moving faster? That's why velocity increases, okay? So now you transfer it, wait, before you transfer, next, my velocity value, can you see that it's in the negative region? That means my V value is negative, ma. So now I copy over, therefore this is V equals what thing? V equals arrow up and minus. I copy down. Arrow up and minus. Okay, so in this case, since my velocity is negative, remember I mentioned to you before, negative means that it is reversing, correct? So if I'm reversing, wouldn't I be further and further away from my start point and end point? That's why if you draw like that, means like you are traveling. Wait. Actually, can. Sorry. Both are correct. Sorry. Now that I interpret it. Yeah, sorry. Yeah, so this is actually correct also. So that means there are two possible answers. Yeah. Sorry. Yeah, good that you got it right. Okay, so both are correct. Okay, why? Because you're moving further and further away from the start point. So can you see this one also, right? From the start point, you're moving further and further away. And the gradient is, sorry, the gradient of this is, wait. No. Wait. Okay, wait. This one not correct. It should be like that. Yep. Okay, so why is the graph like this? The reason is because the gradient is increasing. Yep. So if the gradient is increasing, it should get steeper and steeper. You hold on, let me take a look. Getting further. Yeah, correct. You getting? Okay. So the thing is that next is okay. I think partially the question also never specify like where it is starting from. So I think also like depends. What if you are starting from maybe like like maybe if I'm starting like over here. So if I'm starting over here, and then if I'm reversing, because negative is reversing, right? That means I'm nearer and nearer to start line. So actually for this graph over here, you can also draw it as like that above the x-axis. Yeah, because can you see I'm reversing and getting nearer and nearer to the start line? Yeah, so you need to make sure that it's reversing. So in this case, sorry, the going up part cannot. So that means if you draw the displacement time graph to be like that, also cannot. Yeah, because you should be reversing and then it must be, reverse means we must go back to the start line. If you draw the line going up, right, you are getting further and further away. This is called going forward, right? Isn't this going forward? So you need to reverse, that means go back to the start line, or you get further and further from the start line. So the correct answer should be these two instead. Sorry. I got confused by your answers. Yep, so only these two are the correct answer. Okay, so like that. So the blue one is incorrect. So maybe let me state it clearly. So the red one is correct, the blue one is wrong. Okay? Anyone need me to repeat? Okay, so I repeat one last time in case you're confused. Okay, because based on over here, we interpreted that the velocity is negative. And negative, isn't it reverse? Correct? So if you are reversing, that means I'll just get further and further away from the end point. So either I'm coming nearer and nearer to the start point, or if I'm starting at the start point, I should get further and further from the start point. So the green arrow is this part. Can you see from the start point? I'm getting further and further away. Or the red one is here. When I'm in between start and end, if I reverse, I'm going back to the start point. That's why I'm going back to displacement of 0. That's why the line should be curving down. Then next is, what's the curvature of the line? Is it straight line or is it curved line? You look at the gradient. The gradient increases. It means the gradient should get steeper and steeper. That's why the blue line not correct, because the blue line is getting gentler and gentler. But your answer should be steeper and steeper. That's why you see, in the end, it became like almost vertical line, because vertical is a steeper line. Clearer now? Okay, right? Yep. Okay, so this would be the graph conversion. Okay, then yeah, I think generally that's about it. So for kinematics, it's just either graph drawing or calculation question. Okay, so let's directly look at the worksheet questions to see the questions that is related to this part here. So let's take a look at question number 3. Okay. Yep, so let's take a look at the mock paper now. Okay, I think question 2 also. Okay, we can go through question 2, 3, 4. Because 2, 3, 4 are all kinematics question. Okay, so if you have completed question number 2, this is the answer. Okay, so if you haven't done it, okay, I will go through. Or if you got it wrong, I will also explain. A motorist is traveling on a straight road at a speed of 20 meters per second. She sees the traffic light ahead and turn red and decelerate uniformly. So if she decelerate uniformly means that the gradient of a VT graph, which tells you the acceleration, should be uniform. Uniform means constant. And then decelerate, remember? Deceleration means negative acceleration. It means the acceleration here is negative. Next, she travels a distance of 50 meters from the time she starts to decelerate to when she comes to a stop. So how much time does the motorist need to come to a stop? Okay, so generally for questions, when you want to solve it, I would recommend that you always draw VT graph because VT graph is very useful. You can look at the area under graph to know the distance, or you can look at the gradient to tell you the acceleration. And the axis itself can tell you speed and time. So it's very useful because it can tell you a lot of information. So if whenever you're not sure, just draw a VT graph. So I'm going to explain to you 2 methods to solve it. So one is graphical method, one is the equations of motion. So for the graphical method over here, you know that the area under graph is 50, right? Because distance is area under VT graph. That's why you just take half time base, which is you are supposed to find the time, then times the height. The height would be speed of 20 ma. Then equals to 50. Then you just solve for t. So by right, you solve for t. 2 times 20 is, sorry, half times 20 is 10, right? So that's why it's just 50 divided by 10. So answer is 5 seconds. So this is method number 1. Method number 2 would be using the equations of motion. You use the equation S equals half U plus VT. Then in this case, the final speed, because you come to a stop, so V will be 0. Then you just solve for T. Done. Okay, so if you need the explanation, you please copy it down. So just to let you know, later the answer key that I'll be distributing, right, is the MCQ will only be just A, B, C, D. Yeah, so all this explanation is not in the answer key. So you should copy down the answer, the explanation if you get this wrong. Okay, so I shall move on to the next question. Done, right? Okay, so moving on to the next question. This kind of question, so far I've seen it in RI paper and NYGH paper. Yeah, about like the object throw up and come down. So the main concept is you need to know that the time taken for the ball to go up and come down is the same. Okay, the time taken to go up and come down is the same. That's the most important thing already. Once you know that, likely able to solve. Okay, so based on this information, the time taken to go up and come down is the same. That means over here, you will know that from this time to this time, if you have it, isn't it equals to the time of the upward journey only or downward journey only? That which is over here. So you find the difference between these two. So once you minus, it will be the total duration. And since go up and come down, same duration, that's why you can just divide by 2. It means one way, it would be 1.8 seconds. This side also, one way is 1.8 seconds. Right, like you throw a ball up and it come down, it's the same speed, right? Yeah. Then next is, because we do not know the speed when it's like in the middle of nowhere, like this t equals to 0.5, it makes our calculation very difficult because we do not know what's the v value. So instead, we should use the highest and lowest point. Because from the lowest point, you are supposed to, did they mention anything about the speed? Okay, they didn't mention, but at least, you know, at the top, we know that at the highest point, the speed is definitely 0 speed, correct? Because object, when they reach the highest point, they will momentarily pause. So now we will know that, okay, so I will compare from start to end. So from the start to the end, how long is this journey? It would be 0.5, because here is 0.5 seconds, right? Then you plus another 1.8, this would be the total duration. So the total duration is 2.3 seconds. So now that I know that the whole duration is 2.3 seconds, and they mentioned that the acceleration is 9.81, you can use the acceleration formula, which is A equals V minus U over T. Okay, I see you're like very busy copying. Okay, you copy down first. But after you copy, then I continue to explain so that you can focus and listen to my explanation. I call this question a bit complex. Okay, so should be more or less done copying soon. Okay, so I shall continue to explain. Okay, so now that we know the timing, right? Then now we sub it into this formula, the A equals V minus U over T. So take note, the first direction that the object moves is always the positive direction. So since you throw up, upwards would be positive. That means this 9.81 is a negative value. That's why you should sub in as negative 9.81. If your school used 10, it's because 10 is the rounded off version for secondary school. When you go to JC, if you take JC physics, it's actually 9.81. This is the more exact number. Okay, so since downwards, it will become negative. That's why you put negative 9.81. The final speed would be over here, right? Because you start from here, so this is the initial. Then when you reach the top, it would be the final. That's why final speed is 0. Initial speed, we don't know. That's why you let it to be letter U. But the time, you know, right? The time taken is 2.3 seconds. Then now you solve for the initial speed. But the question is not asking for speed. The question is asking for height, which is the time taken to travel up till over here, 0.5. Yeah, so that's why now you can calculate the height of the tree by using values over here and over here. So over here, we know the speed, right? The new value we calculated, 22.563. Yep. Then eventually here, how to calculate here? So you use the equations of motion, where you don't include V anymore, because I don't know what's the V in the middle of nowhere. Yeah, so that's why you choose an equation that don't have V will be better. I think this will be a better equation. So you use S equals to UT plus half AT squared. So initial speed, you put it in. Then the time taken to reach the top of the tree is 0.5 plus half AT squared. The A is the 9.81 with negative sign. Then the time, it will be 0.5 seconds. Then you square it, then you get the answer. So this would be the height of the tree. Done. Yeah, so this is how you solve it. Okay, so I shall move on. I take it that all of you done copying the correction, right? Okay, so moving on to the next question here. Question number 4, answer is D. So take note that when cars passes each other, what does it mean? That means they are traveling at the same what thing? You all know what are they travel like if they can meet each other, that means they are traveling at the same what thing? Same distance, correct? Not speed, same distance. Right? Because example, one car travel very fast, but the other car is slow. But at the end, they catch up. Yeah, so that means they must travel the same distance, then they can meet each other. Yep, so take note, okay? Whenever they meet, it's always same distance. This is a very commonly tested concept, okay? Must know, okay, I written over here anyways. Yep, so what you need to do is, you have to find the area under graph. Because remember, for VT graph, area under VT graph give you the distance or displacement. Yep, so that means now you just need to go and calculate for each of them. When will the area under graph be the same? I mean, you can tell, right? Until 2 seconds, definitely the area is not the same, because one is square, one is triangle. Obviously, the area under graph is different. So what you can do is you can try out for 3 seconds and 4 seconds. Just calculate what's the area under graph for 3 seconds. And versus over here. This one you can tell is not equal also, because can you see that this triangle doesn't fit over here, right? This triangle is much bigger. This one is smaller. So if I do for 4 seconds, this triangle that's extra can fit into this triangle here, right? Can you see? So if you can fit in, that means the area under graph is the same. Both are still a rectangle. That's the eye power way lah. If you can like eye power and realize that the triangle has the same area as the rectangle at 4 seconds. Because the triangle here you can just bring down and then it will end up the rectangle also. So it's still the same area. But if you can't visualize this, then you just calculate, like just calculate out, then just make sure that the area under graph is equal, will do. Okay, so done. That's all for the kinematics question. For the open-ended, is there any kinematics question? Maybe you can help me to see. I don't think so, right? The open-ended, I think open-ended don't have kinematics. Right? Okay, then we move on to the next chapter then. Yeah, okay. So let's take a look at question 22 also. Because 22 is also kinematics, right? Over here. Yeah, so question 22. Okay, let's read the question together first in case you haven't do it yet. Okay, so a boy on a skateboard moves in a straight line. He starts from rest with an initial acceleration of x and eventually comes to a stop some distance away from where he started at. So yeah, you can see all that. He move, then after that he start to rest. Rest means the speed became 0. And then eventually stop some distance away from where it's at. So for part A, they're asking you, using the information, describe the motion of the boy between 0 seconds and 10 seconds. Okay, so take note, okay, whenever question says motion, okay, whenever they say the word motion, can you arrow out? You must always mention about both velocity and acceleration. Hello, the question got the word motion, right? Can you arrow out? Motion must always mention about velocity and acceleration. So that means if your answer, you never talk about velocity or never talk about acceleration, that means your mark will be gone. Yep. If you notice the answer over here, you see, they mention about velocity, acceleration. Yeah, so need to mention about velocity and acceleration in your answer. Do you have it? If you only have either one, that means your answer incomplete. Okay, so then from here, it's very commonly tested for kinematic question. They always like to ask about the motion. Okay, then next, whenever they mention to you that using information from the figure above, whenever you have graph or table, what's the skill set that you need to have? Whenever they give you graph or table, what do you need to include? Do you all know? Values. Correct, very good. You need to cite the values. So actually for this answer, I think this school was lenient, but for me, if I mark, I wouldn't accept it because by right, you should mention about the velocity value. So like the velocity increases from how much to how much? Yeah. So let's take a look. So in this case, it is from 0 to 5 seconds. So from 0 to 5 seconds, the speed became 4. Okay, so that's why you should write that the velocity increases from 0 to 4 meter per second. And then I'll also cite the x-axis. So it's like both x-axis and y-axis value. Then for the acceleration wise, you look at the gradient because remember, gradient of a VT graph tells you the acceleration. And can you see that the gradient over here? Come, that's your again. Okay, so maybe I just continue on. Just now I asked you Gerald, right? Okay, move on to Abigail. So in this case, for this gradient here, is it positive, 0, negative? What kind of gradient is this? This line, this line. How do you describe the gradient? Is it positive, 0, or negative? Correct, because remember just now I draw it for you, right? Upward is positive, horizontal is 0, downward is negative. So yeah, this is a positive gradient. Then Abigail can finish it up also. How would you describe the gradient? Is it like increasing, decreasing, or constant, Abigail? This same line, same line. It's still the same line. Is it increasing gradient, decreasing gradient, or 0 gradient, or constant gradient? Again? I cannot really tell. Is it increase? Maybe you can point. Ah, yes, correct. Yep, decreasing gradient because it's getting gentler and gentler. Yep, so that's why in this case, the acceleration is the acceleration because it's positive, decreasing. Can you see? That decreasing acceleration. Okay, so that's how we infer the answer. Then moving on to the next part over here. Likewise, how is the velocity? It's fixed at 4, right? So that's why the answer should include citing the values. So should also include, it should stay at 4 meter per second. So like that, then it's more complete answer lah. So then if you want to be like kiasu and then add in about the acceleration, can. But acceleration alone cannot lah. Okay, so if you write about the speed and acceleration, then it is okay. But usually cause it's 0, that's why they never write it in. Done. So this would be the answer. Okay, so I shall move on. Done, right? Okay, so next part over here for part B. Depending on how your school teach, if your school will teach equation of motion, you can use the equation of motion calculation. Yeah, if not, you can use the area under graph. Because remember, distance is area under graph. Or use the equation that has letter S. This one should be okay, quite easy. Okay, then moving on to the next part. Graph conversion again. So this is the answer. Oops, my line fly off. I think you all can tell, right? The negative 0.8 is here. Okay, so can you all do the correction first? After you are done with the correction, then I explain to you using the diagram above. Okay, you copy in the correction first. You want to draw vertical line also can, solid line also can. Yeah. So good that you came today. Okay, so it should be done copying by now, right? Okay, come, let me go through with you how to get this answer. Okay, so what you need to do is you have to look at it section by section. Okay, so let me draw it out first, the axis, A and T. Okay, so we start off with the first section first. So the first section we already mentioned just now, right? That for the gradient over here, it is positive and decreasing, correct? Yep. Since gradient is the acceleration, that's why the gradient, which is the acceleration, should be positive. So you draw in the positive region and decreasing. Decrease means come down, correct? Then does it touch the start line? You look at the next section of. So for the next section over here, this is horizontal. So if it's horizontal, that means your gradient, how would you describe the gradient over here? Okay, next I move on to 千与 So in this case, how would you describe the gradient? Correct, because horizontal line is always zero gradient. That's why you draw on the zero line. That means, yeah, it will indeed touch the x-axis. Moving on to the next section. So for the next section over here, this is like coming down, right? Okay, then how would you describe the gradient? So I move on to Claire. So Claire, how would you describe the gradient over here? Decreasing? No. Why? Because you look at the gradient, the start and the end, the gradient, which is the steepness, is the same. So it is the velocity that decrease, but the gradient, which is acceleration, is not decreasing. So do you know what's the correct answer? Correct. It should be constant instead. So people don't get confused. So over here, V is decreasing, but A is not decreasing. A is gradient. The gradient is the same slantness. So acceleration is constant. Okay, then yep. So if it's a constant value, and this time around, maybe can Claire finish it up. So your gradient here, is it positive, zero, or negative gradient? Correct, because sloping downwards. Sloping downwards will be negative. So right now, constant and negative. That's why you must draw it at a negative value over here, and it's constant at this value. Can understand why the line is like that now? Okay. Then the graph said to draw until t equals to, never say until when. Okay, then just draw finish it. Okay, so moving on to the last part. So for the last part over here, I will continue on to Sophie. So Sophie, how would you describe the gradient over here? Yes, correct. Because horizontal line is always zero. That's why you draw it back to the zero line. Yep, done. So this would be the answer. Yep, so I think that's all right. No more kinematics question, right? Thank you. Okay, so let's move on now to the next chapter then. So we move on to dynamics. Can you all flip your notes now to page 5? So the page that I'm at, you can look at the right side over here. So this is the page number, page 5. Okay, so for this part over here on dynamics, need to know the different terms, right? Like inertia. So you just remember as inertia is just one thing to remain the same. So either it's at rest, remain at rest. Or if it's moving, want to continue to move. Something like, if I let you slack, then of course you want to slack all the way, right? And chill. Why would I want to do homework? Yeah, so inertia is just remain the same law. Okay, then next weight, I think you all know the difference, right? Whether you change or not. Gravitational field is like example, soccer field is the area where you play soccer. So gravitational field is the area where there is gravitational force. Then gravitational field strength G, this one you have to know, the G equals to 10 or 9.81. And then for Newton's law, good news. Don't need to memorize word for word. They won't ask you state Newton's first law. No, they won't. Okay, so yeah, so don't need to memorize the law. What they will ask you is, they will ask you the application instead. Yeah, so that means like if they give you a scenario, then you need to know law. Are you using Newton's first law or second law or third law? So how do you decide which law to use? So you go by this. If it is there is no resultant force, you will use Newton's first law. Because if you read the sentence, all this will happen in the absence of a resultant force. That means all this happen when don't have resultant force. So that's why when no resultant force, you quote Newton's first law. When got resultant force, you use Newton's second law. Because got resultant force, that's why you need to calculate. That's why they then give you the formula. Because you all know, right, that Newton's second law is the formula itself. So that's how you decide which law to use. And then if there's any question related to inertia, you also link it to Newton's first law. So that's how you tell which law to use. Then Newton's third law, it would be the equal and opposite force, which is the action-reaction force. So once you see action-reaction force, it's definitely related to Newton's third law. Okay, so one example of Newton's third law that I usually like to demo is, like for example, if I go and punch the wall very hard, punch. Then if I punch the wall very hard, then ouch, it will be very pain, right? So that means for every action, I will have a reaction. So I punch, my action is punching, what's my reaction? Very pain. Something like that. Yeah, so similar to this topic over here, they will action and reaction force. You need to know that they fulfill 4 criteria and make sure they must fulfill all 4 criteria. If you fulfill 3 out of 4, it's still not action reaction force. Okay. So first, it needs to be, as mentioned here, equal in terms of the magnitude. That means the value, like the number of newtons. Yeah, so it's like it should be like both sides, like maybe 5 newtons. And it must act on different bodies. In physics, bodies just means objects. So it must be on different objects and opposite in direction, as well as same type of force. So I teach you tips that usually, right, the kind of question that they like to test in exam, right, I just tell you now the answer. Then next time you know what to write in the answer also. Is that they usually, their favorite, right, it would be normal contact force and gravitational force. These two are the favorite ones that teacher like to test. So if you're not sure what the answer is, try to choose between these two. Why? Because for example, I take my water bottle here, and then this is like my writing tablet that I'm writing the answer now. So if I were to have a water bottle on top of a surface, you realize that the water bottle bottom is pressing down on my surface. But my surface is also pressing up on the water bottle to keep it in the air over here, right? So that's why normal contact force is action reaction because they are opposite in direction. Can see, right? Opposite in direction. And both are same type, because as long as you touch, means got normal contact force. And it's on different object. One is water bottle, one is the surface. As well as it will be the same value. That's why, same value, that's why it doesn't float or it doesn't sink. Because if it float, that means the upwards force is bigger. If it sinks, that means the downwards force is bigger. Okay, then then next one will be gravitational force. Try not to use the word weight because weight is only like the earth pull the object down. But gravitational force, okay, if you were to take maybe like advanced physics or maybe next year if you were to choose to take JC physics, right? Sorry, I mean like JC at the time, if you choose to take JC physics, they will teach you that gravitational force is the attraction between two masses. That means two objects that got mass, they will attract. So that means in other words, when I jump, right, you can see the earth attract me down, correct? Because when I jump, the earth will pull me down. But I am also pulling the earth up. Because I have mass also. So as long as an object have mass, they can attract each other. So some of my students very creative. They say, what if all the human population, maybe we stand on one of the biggest country, then we all jump together. Then will the whole earth move? So the answer is the earth still won't move because we are still inside earth. That means we are still smaller size than earth. So we are still way lighter than earth. That's why we won't be able to make the earth move. Yeah. But then the Earth is bigger size than us. So that's why when we jump, you can see very significantly the Earth pull us down. Very obviously. Yeah. Then yeah, so that's Newton's third law. Then next you also learn about friction, right? So friction happens only when things are touching each other. And by the way, just a quick recap on, do you all know what are the factors affecting friction? What factors affect friction? For two. Okay, I think I move on to Isabella. So Isabella, what can you name me one factor affecting friction? Correct, roughness of surface. Because if the surface is very rough, obviously there's a lot of friction, right? I know the next one. Then how about Jamie? Are you able to tell me the second factor affecting friction? Not sure. Just now you said you know, is it? What? Want to try? No. Close, not quite right. Okay, I would say it's more of the downward pressing force. Okay, you see, like if I were to, example, I fall down, then got the friction rub off, right? So it's how hard I rub, correct? If I press down very hard and I rub, there's a lot of friction, that would be a lot of blood. But if I rub like gently only, then isn't it like not much friction? So that's why it's not really your own body weight, but it's more of how hard you press down when you rub the surface. That's why it's called downward pressing force. Yeah? So take note that surface area doesn't affect. This one you all should know from primary school. I don't know whether you all can remember, but it was covered in like primary science that surface area does not affect the amount of friction. It is the air resistance that get affected. Okay, so take note, different. Yep. Oh yeah, sorry, can I add on one more point for Newton's third law? I forgot to mention. So take note that for Newton's third law, always how do you write your answer, right? Is because it's the action reaction force, you always name me what the force is. So always tell me the force, like maybe normal contact force, is exerted by who on who. Then since opposite body, maybe like by object A on object B, something like that. So this is how you write. So I'll label this as answering technique. Answering technique means like answering templates. So that means once you follow this phrasing, then you will be able to score the marks. Okay, so answering technique. Normal contact force and gravitational opposite action reaction. Okay, so that means like just now my water bottle scenario, right? The normal contact force exerted by my water bottle on the surface, which is downwards, is action reaction force with the normal contact force exerted by the surface upwards on my water bottle. So this is an action reaction force. So the other one, the gravitational force, is like maybe I let go. If I let go, the water bottle will drop, right? So the gravitational force exerted by the earth on my water bottle to put it down, correct? So this is an action reaction force with the gravitational force exerted by my water bottle on earth. So actually when I lift up, my water bottle is attracting the earth upwards. But because my water bottle mass is too small as compared to the mass of the earth, you don't see the earth being attracted upwards, but there is the attraction. Okay, okay then yep, so mainly like that. Okay, let's before I move on further, let's go through some questions that are related to what I've taught so far. Let's take a look at the mock exam paper MCQ question 368. 368. Oh, 3 is done already, is it? Okay, then 6 and 8 ba. So it's the 3. Okay, so yep, so this is the answer for question number 6. Anyone need me to explain to you? Okay, I hear, oh shit, it means me to go through. Okay, can I'll go through. Okay, so they're asking you which one is action reaction pair. So remember, we said that usually it's either normal contact force or the gravitational force. Yep, so this time round, weight happen to be gravitational force. So this is the gravitational force exerted by Earth on skydiver. Right? The gravity from the earth results in the weight. So if its weight is called gravitational force exerted by earth on diver. So that's why you see now it's opposite. Instead of by Earth on diver, become by diver on Earth. That's why B is action reaction force. Then for the rest, like for example here, if you were to exert a pushing force versus frictional force, these are different types of force. Yeah, because if it's pushing force, I think it's more like normal contact force. Because when you push, you are touching it, right? Something like that. But this is frictional force, ma. Then next one also. This is weight and tension. Also, different type of forces. Next one, a man exerting a force to pull a door versus the normal contact force from the man's hand on the door. Isn't this still the same? It's still, you pull the door, means the force is on the door. Then it's also force on the door. That means it's all by man on door. That means in this case, it is not on opposite bodies, right? Not opposite direction. Okay, or not opposite direction. Or on opposite bodies also can. Yeah, because it's always by A on B or by B on A, ma. It must always be like, swap. But this one is exactly the same. It's by man on door, by man on door. So actually, option D, both are identical. Done copying the explanation, right? Make sure you copy the explanation, okay? Because I told you the answer key that I'll be giving you won't have the explanation. Will only have the A, B, C, D answer. Okay, so I shall move on. Should be done copying by now. Okay, then next question will be question number 8. Question 7 also. Question 7 also can. Okay, then let's take a look at question 7 also. Question 7 is B. Why? Because whenever you see the word constant speed, what does it tell you about the acceleration? 0, right? Then if you link it to the formula F equals ma, if your A is 0, what happened to your F? Your A is 0, your F will be same, maybe got a value 0, right? Anything times 0, isn't it 0? So that means your resultant force is 0. So when your resultant force is 0, that means the forces are balanced. Agree? Yeah, the forces must equal to each other. Are you copying? Can you follow and copy it down? Yeah, so that's why in this case, they must be equal to show that they are balanced. Okay? Cannot be no friction, because if no friction, yet got pushing, right? That means your resultant force will end up become pushing forward. Yeah, then you don't have resistive force. Then if you don't have resistive force, then where got balance? It's not balanced, what? Yeah, so that's why no friction. If it's D lah. A, the friction between the ground is less than the force exerted. Then yeah, you will have a positive resultant force and it will accelerate. So it's the forward minus friction. This would be a positive value. Yeah, that's why in this case, there will be acceleration. Then if it's greater, that means the forward is very small, friction is very big. That means it would be negative resultant force. That means acceleration is negative. That means you will decelerate and slow down. That's why if too much friction, you will slow down, right? Yeah, like that. Can? Can? Okay. Good, sorry, I just saw Joanne's question. You are saying why is the weight of the bottle acting down on the surface same kind of force as the normal contact force acting on the base of the bottle? Because as long as things are in contact means touching, so as long as they touch, that means contact force. So does that answer your question, Joanne? Okay, so I shall move on. You should be done copying by now. Next question, question number 8. So this is the answer. Okay, so I'm going to teach you this technique. Oh, wait, let me just take a look at Joanne's question. Okay, because right, Joanne, because how heavy an object is, it will happen to be also how much downward normal contact force it is. So by magnitude wise, it happen to be the same. But if you say that, weight and normal contact force is the same, then that's wrong. Because in terms of the type of force is different. Because normal contact force only happens on the surface that you touch. But weight is from the center of the object. You get what I mean? So they are different type, but happen to be the same magnitude. So that's why if you want to talk about action reaction force, you should say that the normal contact force by bottle on surface is equals to normal contact force by surface on bottle. So shouldn't say one is weight and normal contact force, action reaction force cannot. They must be the same type of force. Does that answer your question? Or you know? Can okay, that's good. Okay, so come, let me teach you my this strategy. So this is the strategy that I teach my class. Once you use this strategy, right, no matter how chim your dynamics question is, right, you confirm can solve it one. So this is my technique. Other teachers don't use this way. Okay, so what you do is I always teach my student as this so-called L-shaped method. Okay, so what is this L-shaped method? It will be like this. So the L shape would be on the below of FR, you always write in the formula. Resultant force is MA, correct? On the right, you always base on the free body diagram. Let me write down. So below, you write down the formula. On the right, you write down the free body diagram forces. You all know what's free body diagram, right? That means like a dot or maybe a box. Then you draw the arrow like, pulling force, weight, downwards, and normal contact force and stuff. Yeah, so based on the diagram, you see what kind of forces present. In this case, there is an upward force. That's why I'll put it as upward force. And then there is the mass, which will contribute to the weight. And weight is opposite direction, right? That's why I put as negative. And how do you know which is positive and which is negative? You look at the direction of the motion. Since they launch the rocket, usually rocket launch which way? What's the direction of the rocket launching? Upwards, go up, right? Yeah, so that's why in this case, we would take upwards as positive. Yeah, so that's why upward would be positive, weight would be negative. Okay? Then the one with the L shape, you then sub in the values. So like for the upward force, it is 38 kilo. 2 kilo means you need to add 3 more zeros. Then for the weight, the formula is mg, correct? And then just continue to sub in the values. So mass, then you continue to sub in. Can you see? Mass is this value. Acceleration, you need to find. Then you just continue to sub in all the values. Then done. Yeah, so once you use this L shape, no matter how complicated your question is, you will be able to score. Yeah, so you try to make it a practice like that. Whenever you see dynamics question, you try to use this method. All the questions you can solve it already. Yeah, this is like a magical solving method. Okay, so I take it that you're done copying the correction, right? Okay, so moving on to the next part over here. Question, no, this question 9, not yet. Any more questions? Question 5. Oh yeah, it's a dynamics question. Thanks for having that. Okay, so for question number 5 over here, same thing. Okay, this one is so how you solve this kind of string question? I think you've seen quite a few, right? Sometimes got like 2 boxes, sometimes got like 3 boxes. Yeah, so the technique to solve is always the same. The 2 steps would be, can you write down and let yourself know? You always follow these 2 steps, then you can solve it. Step 1, you always go by overall first. Then step 2, you zoom in into any specific box that you want. So what do I mean by overall? You look at it as a whole. So overall here, what is the mass? They say that R is 6 kg, S is 2 kg. So you look at overall. Can you see the first step over here that they solve? You look at overall. Okay, maybe I don't want to use their working. Okay, I shall write out on my own. Okay, so I will go by step 1 first. So step 1, which is the overall, I will go by this way. The resultant force. So F is equals to MA, correct? So for my mass, overall, it is 8 kg. Overall, there is a 16 Newton force. That's why my acceleration is 2. So far, can you agree? Okay, so then done with overall, then next I say step 2, right? So step 2, it would be, you look at the specific box. Up to you, you want to do R also can, you want to do S also can. You can still get the answer. So for example, if we do for R first, for example, later I'll demo to you how to do using S. So for box R, what are the forces? Remember I told you whenever it's dynamics question, always use the L-shape method. So let me now draw out the L-shape. Okay, so for the resultant force, remember below, we always write down the word MA. Then on the right, you look at the diagram. So based on this object, the free body diagram, there would be a force exerted rightwards, which is the tension, right? Because string always have tension. That's why based on my free body diagram, it's tension. And since it's frictionless, you won't have any opposing force. So it's just tension. And in case you're wondering, what about the weight? Because weight is also a force, right? So just based on the question, you see, if I'm moving horizontally, I'm only interested in the horizontal force. So vertical force, you can ignore it. So like weight, normal contact force, you ignore them. Okay? So you only look at horizontal forces. Then next is, in this case, you just plug in the values or so mass, since I'm looking at specifically box or, the mass is 6, so I plug in as 6. Then the acceleration, you use back the original value here. Why? Because if overall, they move with an acceleration of 2, and since they are tied with the same string, wouldn't they move together at the same speed, correct? Because you tied with the same string, you move at the same speed and acceleration, That's why the acceleration of 2 for overall is also the specific acceleration of box off. Agree? Okay, then next is, you just solve also T, you will get 12. So this using box off. But for step 2, you want to use box S also can. Because I said that step 2 is use specific box. So likewise, use the L-shaped method again. Can you all follow and copy this down? So based on the L-shaped method, this time round, I shall ask you all instead. Just now, I asked until Isabella, right? Have I asked Jamie, haven't I? I asked you already, huh? Okay, can. Then I continue on. Next would be Chloe. So Chloe, can you fill in for me for this L-shaped box? So below F all, what should we write? Correct, good. Then on the right for box S, what are the free body diagram forces? What should I write here? You know? Hmm? Again, I cannot hear you. So based on the, this is like the free body diagram, remember the L-shaped method that I taught? So based on box S, what are the forces present on this box? Correct, 16 Newton minus the tension, because there is this like, the string over here and the box like a burden, right? Like I want to move forward, but I cannot move forward. Yeah, so that's why there is this tension that is dragging it down. Yeah, so that's why tension is in the opposite direction, so you minus tension. Then now you just plug in the values. So mass of box S is 2 kg, right? Then acceleration, I said it is the same acceleration of 2, then 16 minus t. So you see, once you solve for the t value, isn't it back to 12 again? Yeah, so you just follow this method. Whenever it's a box question, always step 1 and step 2 like that. Then always use the L shape. You see, no matter what kind of question, you use the L shape, you can always solve it out. So this is a very good technique that you should actually pick it up. Yeah. Chloe, the next question later still directed to you because you couldn't answer correctly. Yeah, so Neha pass. Yeah, so later the next question to you. Okay, so I think no more dynamics question already, right? Okay, I haven't finished dynamics notes yet though. Okay, let's finish up the note first. Done with the correction, right? Okay, so then next part over here on the free body diagram, just okay, all other free body diagram, I think that you know how to draw it. I go through friction instead, because friction I think is quite confusing. So I'm on page 5 of the notes. Okay, so for a person walking, take note, a person walking, the way that the person walk and the friction happen to be the same direction. We always say that friction always oppose motion, right? But in this case, how come it's not in the opposite direction as the motion? The reason is because in order for the person to walk forward, the feet must press backwards, correct? So if you press backwards, can you see at this point here, it's actually going to the left. That's why friction points to the right. Another very commonly tested question, this one, you realize, bicycle that is moving forward, the friction can be opposite direction. Like, what's going on? The reason is because of the wheel. Is it a free moving wheel or is it engine powered wheel? Engine powered wheel means that there is maybe like, the car engine, or maybe like, I got a pedaling force. It means like got some external force exerted on the wheel. That's called engine powered wheel. Free moving wheel is just, it moves freely. Also, maybe, when I pedal, then okay, this one will move forward. Yeah, so free moving wheel is like, I don't have any force exerted on it to force it to rotate. Yeah, so you see the bicycle chain, not connected to the front. That's why the front is not engine powered. The front is free moving wheel. Once the wheel is different, your friction direction will be different. Okay, so I explain engine powered wheel first. Engine powered wheel is the one that you usually do in school. Yeah, which is that, you see, like if I pedal, I would usually exert a pedaling force this way, correct? So let me write down, the pedal force is this way. Can you follow and copy it down? The pedal force would be this direction. So friction always opposes motion, right? So you see, friction points to the left, while pedaling force points to the right. So this one, okay, right? No problem, right? This is like straightforward. Okay, it is the free moving wheel that is confusing. Okay, so before I start with the free moving wheel, let me write clearly, okay? So you need to know that for the back wheel, what are the forces present? We have the pedaling force. We also have frictional force. If I were to look at the front wheel, do I have the pedaling force? Don't have pedaling force, right? Because don't have bicycle chain linked to it. Then now, since bicycle is cycling along the road outside, road confirm got friction, correct? So that means the force present, it will only be frictional force. I ask you a question. If you imagine, okay, let me use something round, like my water bottle. Okay, so take it that this part is like the bicycle wheel. If my bicycle wheel is on a surface that is very no friction, like maybe I put a layer of oil, or maybe I put a layer of water, and you like very, very smooth, right? What do you expect will happen to the wheel? Will the wheel rotate or what? The wheel by right should not rotate, right? Because if I, for example, like that, so if it's very slippery, it will just glide down without rotating. So maybe I use my motor cap instead, because got extra thing coming out. Yep, so by right, if it's a very oily surface, the wheel should just glide downwards without rotation, correct? So only if it's rough, then the wheel will then rotate. Do you agree? So that means you need to have friction to rotate the wheel. That's why for the front wheel over here, your friction is to rotate the wheel. And since you know that bicycle is moving to the left, to make the bicycle move to the left means my wheel need to rotate this way. And what is the force that can rotate the wheel? I told you, right? Like this scenario, you need to have friction. Then you can rotate the wheel. That's why it is the friction that rotate the wheel in this direction. That's why friction is the direction of the rotation. Can understand? Yeah, so that's why the direction would be opposite, because the friction at the back is to oppose motion. But the friction in front is not to oppose. There's no force to oppose. Yeah, so that's why the front one is to make the wheel rotate. Because if you don't have friction, right, the wheel won't even rotate. That's why how come the wheel rotate is because of friction. And that means friction has to be in this direction. That's why end up it is opposite. So if exam you find that, oh, I can't remember free moving engine power, very confusing, right? What you do is you remember one, then the other one will be opposite. Like if you are used to the engine powered wheel, which teacher always go through in school, you remember this lah. Then the free moving wheel, you just choose opposite. Can?
How do you draw the free body diagram?
So if I give you the wheel over here, if your school use a dot, or depending, some school use a square, then you just draw it that friction point to the left. Yeah. But usually when it's like wheel kind, they will usually draw the wheel itself, then label on the diagram itself. Yeah. So usually they won't give you as a box.
So when you draw if they ask you to draw FBD or something
Cannot, they can't give you as one box to represent both wheels because the friction is different direction. Yeah, so they will have to give you two separate wheels. Yeah. Okay, so okay, right? I shall move on. Okay, so moving on to the next page over here. So remember this topic got the scale vector diagram, the one that you need to draw using like protractor and all. Okay, so this is a technique that I usually teach, which is you look at the object. Are they at equilibrium? That means stationary, or are they moving? So if the object is stationary, that means not accelerating, correct? So if you are not accelerating, that means F equals ma, your F will be 0. Yeah, that's why in this case, you cannot draw the resultant line because no resultant force. So you can't draw this like, double arrowhead line because no resultant force means no resultant line. Next. So that means if you were to not have resultant line, your arrow will just keep going in circles. Something like, let me just show you quickly. It will look something like this. Can you see? It point up, down, right, up, down, right. Do you realize there is no start or end point? That's why you can't draw a resultant line. So for object that is like suspended here, stationary, you just make sure that the arrow just keep going in circles lah. You cannot have the arrow clash. Your arrow must keep going in circles. So that's what I meant by over here. The arrows will just keep going in circles. Next. If your object is moving, then maybe it's like accelerating, then yeah, you can draw the resultant line. So take note that for the resultant line, it will be this line, the line with double arrowhead. So resultant always start from start point to end point. So that's the direction. Always from start to end point. Okay, so let's take a look at the triangle law over here. So for triangle, okay, so usually for scaled vector diagram, there's two ways to draw. Either you draw triangle or you draw parallelogram law. So personally, I strongly recommend triangle law. The reason is because for triangle law, you can actually it's a lot of benefits. Number one, can save time. Because you see, for triangle law, you only draw 3 lines. If you only draw 3 lines, isn't it save time in exam as compared to this? How many lines? 1, 2, 3, 4, 5. You draw 5 lines. Isn't it more time consuming? An exam is like so time tight already, right? Draw less lines to save time. And then next is in terms of accuracy. You see, in every line, you off by 0.1 cm. That means triangle law, at most you just off by 0.3 cm. But parallelogram law, you off by 0.5 cm. Isn't the error more significant for parallelogram? Yeah, so that's why I'll recommend you to draw using triangle law. So that's the second reason. So one is time, one is accuracy. Third is most question you can use triangle law. Not all can use parallelogram law. Why? Because parallelogram law only for 2 forces, right? Got these 2 forces, you duplicate. Done. But if you got the third force, you cannot use triangle law. You cannot use parallelogram law. If it's 3 or more forces, you have to use triangle law. So triangle law is the best of 2, 3, 4, 5, 6, 7, 8 forces. Any number of forces, you can still use triangle law. Yeah, so triangle law is the best lah. Yeah, cause 3 clear advantage over parallelogram law. Okay, so for triangle law, yeah, as mentioned, when to use is when there are a lot of forces. And the method would be you have to shift or rearrange the line such that the monster, okay, the monster over here I'm referring to is like, you know, you play cartoon, you play game or what, you know, or the cartoon character, the monster jump, that kind. Yeah, so you imagine if you have a cute little cartoon character monster over here. So if he start here, then he will be like, oh no, I don't know like how to walk. Should I walk up or should I walk down? Yeah, so that's why in this case, you need to rearrange the lines such that the monster has a clear, straightforward path to walk, that the monster don't need to be headache, and then they know how to walk. So what you need to do, so triangle law, take note, some students very smart. Oh, triangle law, like that law, triangle law. No, cannot. You have to rearrange the lines. So maybe I can shift this line up. So then now my monster know how to walk, right? The monster walk up, then walk down. So that's why resultant will be start to end. So this would be the resultant. Or you can shift this line, come down. So if you shift this line, come down, that means the monster walk down, then walk up. Then the resultant is start to end. Yep, so you see the monster know how to walk down, then up. Yeah, so that means you need to rearrange the line such that the monster know how to walk. I show you a wrong example. A wrong example would be like this. I shift this line here. Wow, then like that, the monster should start on top of start at the bottom. Yeah, the monster you need to split half man, cannot be, right? Yeah, so like that is wrong, because the monster don't know where to start at. Yeah, so just always based on this guideline on how the monster can walk. Okay, then once you're done drawing, things to check. So can you try to remember this checklist? So once you draw finish, you check whether do you have all this. Because this is also what us as teachers, we will check your answer and see whether anything missing, anything missing, and then we start to deduct your marks. So first is you check whether do you have the scale. So take note that for scale, the recommendation is 1 cm is to something. But if you want to write as 1 Newton is to how many cm, also can. 1 cm is just the recommended starting point. Next, for your scale over here, make sure that it must be in multiples of 1, 2, and 5 only. Hello, can you follow and copy down? It has to be in multiples of 1, 2, and 5 only. Yep, so that means can be 1 is to 1, 1 is to 4, 1 is to 20, also can, because 4 is 2 times 2. 20 is 2 times 2 times 5, right? Yeah. Okay, then next would be the magnitude, because you know this is the vector diagram. Vector means you must have both magnitude and direction. So for the magnitude, do you label all the magnitude? So don't write the CM. If you write CM, teacher is going to ignore. Because CM is just for yourself to know, okay, how many CM I need to draw. But don't label the CM. Okay, teacher won't be looking at your CM. They only look at the Newton that you label. Next, must include the arrowhead. Okay. If the arrow is from the question, you can label at the end, or you want to label in the middle also can. Both are acceptable for line from the question. Okay, but if it's resultant, right? Resultant strictly only in the center, cannot at the end. Okay, resultant must be in the center. Then lastly is the angles. So maybe like example, like this question, maybe I got label here, like maybe 30 degree. So if I label, then you must make sure you include the 30 degree. So that means whatever angle from the question, you need to include it in. Or maybe the answer, they ask you, what is the angle from horizontal for the resultant force? And then if you got like label and answer, the answer is like 20 degree, then make sure that your answer that 20 degree, you must show it in your diagram. Because teacher need to know where you measure that 20 degree from. So you need to label your answers degree in your drawing. Yeah. And then next is whenever you label, where do you label? We always label from arrow tail. Meaning, like example, if this line, you always label your angle from here. You don't label your angle from here. Yeah, so this is incorrect. Yeah, you always label from the arrow tail, not from the arrowhead. Okay, so angles always label from arrow tail. Yep, done. So this would be the checklist. So as long as you have everything in, then most likely if you draw accurately, then your answer will be correct. So once you are done noting down, then I'll move on. Okay, so moving on to parallelogram law. Parallelogram law, it is about the duplicating of the lines. So you see like this line, you duplicate over here. This line, you duplicate over here. Then how do they move? Start from here. The line is pointing down, right? So down, up, then down. So you end here. So start to end, that's the resultant. Your answer will still be the same for parallelogram law. Then same thing, just make sure that you check and make sure everything is in here. Okay, so yeah, let's take a look at some kind of like question that they might ask you. So some questions are very simple, like they give you two forces, or you find the third one, or that one very simple. If they give you like all the values like the magnitude and angles, but not all questions so friendly, right? Yep. So okay, this one I already mentioned just now to you that if it's stationary, just make sure you keep drawing in circles, okay? Then remember final answer to write out. Don't expect the teacher go and hunt for your answer. Because you see over here, if they ask you find the magnitude of fx and angle theta, right? You don't just draw like that. You need to write out properly. You need to present your answer nicely. Okay, teacher is not going to hunt in your drawing. Is it this number? Or is it this number is your answer? Or is it this number? Teacher won't go and guess. You write out properly. Then if your force is like yeah, I think just mainly like that lah. So then sometimes if the question were to give you in a way that they only give you one magnitude. So maybe like if they give you only one magnitude, then you need to find the magnitude of the other two. Usually it's in the form of like you hang something from the wall. So maybe like this is the wall. Then maybe this time round I hang maybe a photo frame. Yep, so right now, okay, this is a photo frame, for example. Yep, then I tell you that, okay, for the object, it has a weight of maybe 50 Newton. Then now, I said that since got string over here, there is tension, right? Yep, and now if they say that, okay, my string over here happen to be like maybe a isosceles triangle, 60 degree, for example. Then now they ask you, solve for T. Do you know how to draw then? You only given one magnitude. Then how to draw the other two lines? So what you need to do is, for this kind of question, right, if only one magnitude is given, you draw the one that is given first. So that means my answer will be, I will draw the downward weight first. So this one is like 50 Newton. So you have a scale line. You have a scale, you draw a 50 Newton line. Then for this two, I do not know how long to draw, right? But you have the angle, correct? So you draw according to the angle. So that means like from horizontal, so I draw from horizontal, I draw a line 60 degree up. But since I do not know how long it is, you just draw as long as possible. You draw it super, super long. Then this is 60 degree. So this is the line that points to the top right. So remember, the line, you cannot change the orientation. if my line is pointing to top right, you must stay pointing to top right. You cannot suddenly change to point right. Cannot, must stay in the same angle. Still point top right. Then how about this line? You also know 60 degree, right? Then we draw it in, no? So in this case, this part here would be 60 degrees. Yeah, because can you see that there's alternate angle, letter Z? And so based on the alternate angle, this is 60 degree, which is this one over here. Yep. So then in this case, you draw a 60-degree line such that it's so long that it intersects. So once they intersect, this would be the actual length of the force. Then you can use your scale to measure how long is this line. Once you know the length, you use the scale to convert, then you will know the force. Okay? So that's why sometimes it is possible that question only give you one magnitude. You need to solve for two others instead. Yeah, so this is how you draw. You just draw accurate to its angle, let the line intersect, then the length will tell you the magnitude. Can understand, right? Yeah, so this is another kind of question that they like to ask, the more chim way, lor. Yeah. Okay, so now that we are done, can you now take a look at your mock exam paper, question 21? And can you check through the checklist? Do you have everything in there? Now that I tell you. Yeah, so now let's see whether you can improve on your answer or not. So can you now check your mock exam, question 21? Look through the checklist. Do you have all 4 items present?
Why? Instead of getting $5 from Starbucks. Yeah, we can figure it out. I can't get my projector.
So can you check, do you have the checklist fulfilled for all 4 points for your question 21?
I can't get my projector.
Okay, so I shall review the answer. I think should be done checking by now, right, for the checklist. Okay, so the correct answer is over here. Let me shrink it so they can fit everything in. For those of you who haven't do this question, no worries, like I'm giving the answer key. You can go home slowly draw it out. You just listen to my explanation first for now. Okay, so as mentioned, for the triangle law, you always must make sure that the monster has a clear cut path, clear straightforward path to walk, right? So you see, in this case, the monster will know how to walk, right? Because he walked to the right, then he walked to the left. So that means you start from below, you end on top. That's why the resultant is upward. Then remember I told you, angles shown in the question must be shown in your answer. So for this question, they actually showed you the 30 degree and 45 degree. So in your answer, you should include the 30 degree and 45 degree. So that means in this case, the 45 degree, it would be over here. Yeah, so need to label 45 degree. Okay? So all the angles shown in the question must be labeled. And every single line, do you have the magnitude? Okay, so for those of you who managed to complete this, you follow me and check. Number 1, do you have the scale? Where's my scale over here? There, over here. Do you have the scale that is in multiples of 1, 2, or 5? Number 1, do you have the scale? Number 2, do you have the magnitude? So do you have the Newton for all of them? Magnitude. Number 3, you need to have the arrowheads. Yep, because vector has both magnitude and direction. So can you check your arrows? Are they pointing in the correct direction? And the line, if point top right, must still point top right. Right? You cannot change it to become bottom left instead. Yep. Then lastly is the angle. So for the angles, do you have it? Then over here, the 45 degree and 30 degree. Then finally, present your answer properly. Write out your final answer. Done. So this is the range of acceptable answer. So if your answer is beyond the range, then you will need to redraw it. Yeah. Okay, so done. That's all for this part here. I shall move on. I'll give you the answer key, and then you can slowly do your correction. Okay, so moving on to part B, they said that hence or otherwise determine the weight of the circus performer. So mainly is because the object is in equilibrium, stationary. Remember I told you, stationary means no resultant force. So if your upward force is 550, that means your downward weight must also be 550, so that both 550 will cancel off, balance out to become zero resultant force. Yep, done. So that's the answer for B. So I shall. Oh, I think done already, right? Yeah, that's the next question already. Okay, let's continue back to the notes because I haven't finished dynamics yet. Yeah, dynamics is a very big chapter. Okay, so moving on to the next part over here. Do you know that when object is undergoing free fall, that means like it's falling down, you know that with and without air resistance, the graph is totally different. Yeah, so be careful, With versus without air resistance, the way they fall is totally different. If you don't have air resistance, like vacuum, right, the object will fall down at the same speed, be it heavy or light. Okay, so let's add it in. So if it is heavy object, they are not dependent on mass, correct? Light object, all same graph, okay? So heavy or light, same graph. But you see, once got air resistance, heavy and light would be different graph. Okay, so let me now show you this video where they actually do the feather and bowling ball. I think most of your teachers should have shown you before lah. So you can use this to remember lor. Yeah, so I'm going to like mute it and fast forward because I don't have time to show you the whole video. So what happened is that they are going to release a bowling ball and a feather. Obviously, two are different weight, right? In a vacuum. So this is actually the world's largest vacuum chamber. Then you take a look at what happens when it is falling down. Okay, this video is slow mode. In real life, not so slow lah. Yeah, so this is slow mo. So you look at the speed that both of them falling down in vacuum. So what do you notice about the speed for the both of them? The speed is exactly the same, right? So try to screenshot this, because I know if you want to screenshot words from notes, very hard to screenshot. But screenshot picture, easy to screenshot, right? So you can use screenshot this. Okay, so you screenshot, then remember, vacuum, heavy and light object fall at the same speed. Yeah, so that's why if you look at my graph, then heavy and light, I will draw it the same line. It's the same speed. The reason is because you might be thinking that maybe it could be like you might think that if I am having a heavier object, wouldn't I have like more kinetic energy? Then wouldn't I fall faster? This might be usually the thought process that students have. That's why they always think that heavy object fall faster. But now you must take a look at this part here. What's my question? My question, am I asking you about kinetic energy? No, right? This is dynamics topic, it's forces. It's not energy. I'm not asking you energy. True that heavier object got higher kinetic energy. But over here, I'm asking you about speed. And you learn even from primary school that speed, what's the formula? It's distance over time, right? So speed, you look at the formula, does it have the letter mass inside, like m inside? It doesn't have the letter m. So since it doesn't have the letter m, that's why mass don't affect the speed. Yeah, so like what you saw in the bowling ball and feather scenario. Oh, I just noticed the text from Adviata and Error. If maybe I can go through with you like maybe after class. So maybe after class you can stay behind. I can explain to you. Sorry, I missed your question just now. Okay, so then next would be that for object that is falling in presence of air. So take note, okay, when there's air, then the mass will affect, you see, heavy and light. Okay, so let's write it down. So that let's write it down likewise. Mass affect the speed. Why mass affect the speed? Because do you also remember what is this horizontal part over here? What's the name of this velocity called? Terminal velocity, correct. So at terminal velocity, what is going on? You need to know that to reach terminal velocity, what's the criteria? How to reach terminal velocity? Maybe I ask that Chloe again. Correct. Correct. Then can you be more specific? What's the upward force and what's the downward force? Correct. The air resistance and the weight are equal to each other such that the resultant force is zero. So when resultant force zero, that means F equals ma, A is zero, right? If you're not accelerating, that's why it will be constant speed. Can you follow and copy this down? Write it in. So in this case, in order to reach this horizontal line, if your object is heavier, that means my W value is bigger, right? That means my air resistance need to be bigger. How do I get bigger air resistance? Do you also remember what are the factors affecting air resistance? So what are the factors affecting air resistance? Got two factors. What are they? Surface area, correct? And yes, correct, the weight of the person. It's not weight, sorry, wrong. Speed. Yeah, cause example like now, I stationary, no wind blowing at me ma. But if I run, or maybe I sit on a speedboat, or I sit in like speed car, like a race car or what, they can feel a lot of wind at you, right? So that's why speed would affect air resistance. Yep, so that's why in order, if your weight is so big, how to have a very, very big air resistance? That means I need to move at very high speed, correct? And that's why you see the speed is higher value because higher speed then can have higher air resistance to be equal to the greater weight. Yep, yep, like that. Okay, so now I have a question for you. So right, if I were to say that, okay, so you see this object falling. So now let me change my question. Instead of object falling down, if I throw the ball upwards. So now my question is, okay, can you find somewhere to write it down? I don't know below or what, got space or not. You find somewhere, okay, I'm going to doodle on top. Okay, let me get a white color box so that I can like find space to write. Quite no space now. Let me, okay, like that. Okay, so if I were to say that I have an object that I throw up and then it comes down. So now my question is, can you tell me what happens to the acceleration at each point? So can you tell me what is the acceleration over here? What is the acceleration over here? And what's the acceleration over here? I want the value and direction. So can you write down for me? So, okay, you follow your school. Okay, so if your school say free fall is G is 10, you write 10. If you find that, if your school say G is 9.81, you write 9.81. So can you fill in, like, is it like 0 or 9.81 or what, or is it some other in-between values? Yep, so can you fill it in? So tell me both the magnitude and direction, because acceleration is a vector quantity. Okay, now write down the magnitude and direction. Write it in. Both the magnitude, I want the number and direction. So can you write now, is it upward or downwards? Direction only got two, right? Up or down? Yep, everyone write it in. What's the magnitude and direction at the tree position? If you're not confident, I would recommend that you still write your answer, because even you get it wrong, it's okay, it's your own paper, right? It's not even an exam. Yeah, then you just learn from mistake. Okay, so how do you know which side is positive? We always take the first direction as positive. Since the object is moving up, we always take upwards as positive. But this time around, don't need to write positive, negative. Like, just write upward, downward will do. Lor. Yeah. Done writing in for all three? Okay, then I just continue on. Just now Neha answered already, right? Then I move on to Elizabeth. So, Elizabeth. Okay, so in this case, how would you describe the acceleration here, the magnitude and direction? What do you write? Do you write anything? You never write anything, is it? Eh, 千惠, sorry, say I call wrong name, sorry. Yeah, so 千惠, what's the acceleration over here? Huh? Yes, correct. It's 10. But by the way, because gravity pull is downwards, and then since we are pointing upwards, so maybe we put as negative 10. Okay? That means, yep, like that. Okay, so then next would be that need to include the direction also. So what's the direction of the acceleration here? Wait. Yes, correct. Because gravity always pull downward. Okay, so even though you throw from your hand, it is the speed that is different. Okay, so object on Earth, you know, right? Object got weight, weight always downwards, right? G equals to 10. Okay, then now I move on to Loy. So Loy, what do you think is the answer over here? 10. Do the rest of you agree with 10? The rest of you not sure. Loy is correct. Not 0, surprise. Why is it not 0? Because it is the V that is 0, not the A that is 0. Because as long as you are On Earth, you will always experience the gravitational force, which is G, which is 10. That's why the acceleration is 10. Okay? Some more, in this case, it's like free fall, right? It's like falling in the air. I'm not exerting any force on it, so that's why it's free fall, so it's G. That's why in this case, the direction would be still downward. Because as long as 10 is downward gravity pull, so it's downwards. Okay, then next I move on to Elizabeth. Yep, so for this case, for this part here, how would you fill in for the acceleration? Yeah, so throughout is always the same answer. Okay, so don't get tricked. This is one of the kind of question that usually student will answer wrongly. Yeah, so it's 10 throughout. Okay, it's always 10 downwards. Clear? So don't confuse between velocity and acceleration. As long as you're on Earth, you experience gravitational acceleration. So it's always G value. If they ask for speed, then that's another matter. The speed will change, of course, as you go up and come down. Okay?
What about the negative sign?
Oh, okay. So if all of them downward, then all of them should be negative. So all three are all negative then. Okay, so let's move on. Done copying? Have you all copied down the answer? Okay, so moving on to the next part over here. So in this case, need to know the common examples like your ball throw up into the air, then come back down, or like maybe the ball I throw down, bounce up. You also need to know how it is. So as mentioned just now, as long as free fall, you see, it's always fixed at 10. So can you label, if your school teach you at 9.8, you write 9.8 lah. If your school teach at 10, then you write 10. Oh, sorry, write wrongly. 10, 10, negative. Okay. So remember, throughout the whole duration, is always fixed at G value. So in this case, for the object that is throwing up into the air, you all know, right? When you reach the highest point, the speed will become 0, correct? At the highest point. Okay, so now since I labeled for you the highest point over here, now your turn. For this graph over here, do you know where is the highest point? Can you maybe also like mark with a cross? Where is the highest point for this graph? You can read. Where is the highest point? Do you all know where to mark the cross? I move on to Sue. Okay, then Sue, can you tell me where do you mark the cross then? Or maybe you want to show me from your worksheet. Do you label on your worksheet? I take a look. Let me see. Oh, not correct. Okay, Sue labeled here. This is incorrect. Okay, why? Because this point, okay, or rather, this vertical line, do you know what is happening during this vertical line?
Oh, I thought you went from the
Anyone knows?
I thought it went from the
Do you know what's happening during this line? So you read, the ball released from the ground. Isn't this the highest point? Because you release, right? Then when you release, then how come here, zoom, like that? What happened? Correct. This part is when you hit the floor. That's why you quickly change direction when you hit the floor, right? Because when you come down, versus you go up, change direction, positive become negative velocity. That's why it hit the ground. Then after that, once you hit the ground, it will bounce up. So once you reach here, it is the highest point again. So need to know how to interpret graphs law. Yeah. Yeah, in a way, something like that. So if there is energy loss, then it won't reach back the highest point. But if like maybe perfect scenario where no energy loss, then that would be the next highest point. But roughly just wanted you all to know like when is high and when is low position. Yeah, like that. Okay, so I think the displacement you all can tell, right? Like this one is like go up, come down. This one is because if you are going down, then it would be getting further and further away from the start point. Then later when it bounce up, you're getting nearer and nearer to the start point. Then the gradient would correspond to the velocity here, because velocity will increase. That's why gradient keep increase. Here the velocity decrease. That's why the gradient here decrease. Because gradient of displacement time graph tells you the velocity. Okay. Then next on terminal velocity, usually question like to ask this kind of question, like they ask you to explain the whole graph in terms of forces. So when they ask you, this would be like, I would say like the model answer lah. So this is the only, I think the whole chapter, the only thing you need to like really memorize is only this thing, because Newton's law also don't need memorize. There's nothing much to memorize lah. So this is the only thing that I would say is like need to memorize. So I'll label it as answering technique. Yep, so this would be the how the parachutist move. Yep, like that. Then moving on. Oh shucks, I just realized I teach the wrong chapter. I'm supposed to teach kinematics, turning effects, and lens. Then I teach dynamics. Okay, never mind. You also tested on dynamics, right? So okay, still on. Oops, sorry. Remember wrongly. Let me see. It's okay, right? Okay, so wait. For the dynamics, can you help me double check for the open-ended? Is there any more like question on dynamics that I should go through the correction? Question 23, is it? Okay, then let's go through the answer.
Oh no, I didn't just
Okay, question 23. Yep. So you check your answer, bah. So remember I told you for dynamics, always need to use the L shape. Do you use the L shape? Yeah, so you use the L shape, you can solve already. Should be okay, bah. Quite easy, right? Okay, so I shall move on. The part A should be correct. No worries, I'm giving the answer key, so no rush copying the correction. Okay, so then moving on to part C over here. So for part C is that okay, let me clear screen. Yeah, so for part C, they're asking you describe and explain the motion of the balloon when the air resistance reaches this value. So as mentioned just now in kinematics, whenever got motion, include both the velocity and the acceleration. Let me see. B, A. Okay. There are many possible answers. Yep, so it can be this. Yep, then once your A is negative, that means F would be negative. Yep, so if F is negative, that means it's in the opposite direction. Done. Maybe I think you just mark instead of copying the correction, because copying or correction, you can slowly copy it at home. You just tick and see whether do you have the marks. Okay, so I think that's all right. Yeah, this is another question already. Okay, so then moving on to the next chapter on turning effect. Oh, this one you can do it very fast. So for turning effects, all these I think you already know. Among these, I would say the only one you need to memorize is this one. The rest might be tested, but very seldom tested. Their favorite is always the principle of moments. Okay, so for principle of moments, it will be linked to this. So moment is force times distance. Take note that for moments, it is force times distance. Do you realize there's another quantity that is also F times D? What is the other quantity that is also force times distance? Work done, correct. So take note, okay, that work done also force times distance. But what's the difference? Because both are force times distance. It would be the direction of the distance. So for moment, the distance is perpendicular, while for work done, the distance would be parallel. Meaning, for work done, it's like that. Like, your force, if you exert to the right, your distance is to the right. Then for moment, it would be 90 degree. Yeah, so that means like if I were to have like the usual case is like the seesaw case, right? Yeah, so maybe like in this case, if my force is downwards, my distance would be horizontal. So can you see it's 90 degree, while this is parallel. So that's the main difference. Okay, then moving on to the next part. So for moments, take note, okay, that your distance, it must always be from the pivot to the force. Must be from the pivot to the force. Yep, so follow and copy everything in. Okay, then next is principle of moments. So when you need to do calculation using principle of moments, this would be like the template on how you present your answer. So you write down that taking moments about like which pivot. So maybe if they tell you, okay, this point over here is like maybe point X, and then you say taking moments about point X. But if the question never tell you what's the name of the pivot, then you just say taking moments about the pivot. Then sum of anti-clockwise equal to sum of clockwise. Then you just sub in all the values like the F times D values to calculate. Done. So these are just some examples of the formula. Okay, then the next part would be take note, okay, this topic, right, they always like to trick you and include dynamics question. That means, right, even though you see this question, yeah, I know turning effects of forces question. Then the trick that students end up get tricked is they only think of moments formula. So they keep using what F times D and stuff. But take note, this topic, they like to include forces. You see, upward force equals to downward force. So this one must remember. You know, a lot of students tend to forget. I'll put a star over here. Can you put a star also? So take note that when object is in equilibrium, equilibrium meaning stationary, the resultant force must be zero. That means it's not moving up or down. And then in terms of rotational wise, that means in terms of moments, must also be zero. So resultant force, zero. Resultant moment, also zero. Yeah? Yep, so that's why you can actually use the upward force, downward force as calculation. But of course, you want to use moments also can, just that it's more complicated. Upward equals downwards is very easy. Yep, so remember this, don't forget. Done, noting down, right? Okay, then next part here on center of gravity. So need to know that center of gravity is usually at the spot where most of the weight is at. Oh, wait. Before I move on to the next page, can we go through some of the practice question in the mock paper first? It will be question number 9. Okay, so here's the answer for question number 9. So answer is D. So how to get the answer of C? The reason is because if you want to have the greatest moment, I told you, right? Moment, the formula, which is F times D. The D value here, it has to be perpendicular. So which one is perpendicular? It will be C. That's why you choose C. Okay? Just to let you know, why D is smaller? Because you can also use a bit of the scale vector diagram understanding. To get this line, right, it means that it comprises of a vertical force and a horizontal force. So if you look at this vertical force, isn't it shorter than C? Can see? Yeah, so that's why D, the vertical force is smaller. If you look at B, how to get B? B is a combination of I exert a leftward force plus an upward force. So can you see that for B, the upward force is also smaller? Yeah, so that's why for moments, you just choose the perpendicular one. Because if you choose anything that's diagonal means it's shared between horizontal and vertical. So once you shed and then you speed up, then it's not as great as it is just purely vertical. Yeah, so that's why it's the answer. Yes. Again, how to draw? Oh, okay, so maybe like a plank here, then this is a wall, maybe a string like this kind of like weird angle. Then how you draw the perpendicular distance, is it? Okay. So then what you need to do is first you need to locate the pivot. So maybe this object you can see, right, if I pull it hard enough, this whole thing will swing up. That means this point here would be the pivot. So that means if you were to have a force, a tension that is in this direction, that means the perpendicular distance would be over here. How to get? You mean like the how many cm it is? That's only if they give you like the. Okay, your force you can actually extend it out. Yeah. So okay, so maybe let me see. Okay, like over here, the force is here. So where is the perpendicular distance? You realize the pivot is here, the force is here. They are not touching each other, right? So since let me highlight it. Since this and pivot are not touching each other, then how do you draw the perpendicular distance? You can either extend out the pivot or you can extend out the force. So both can be extended. Yep. So either I extend out the force. This is the perpendicular distance for option C. Or you can extend out the pivot. This would be the perpendicular distance for option C. Okay, yeah, so you can either extend out pivot or you can extend out the force. Okay, if you are very scared with the insect, can you see over there near the toilet above the cabinet, there's an insecticide. You can take the pesticide to spray it. But don't spray too much because if not, the smell will be quite strong. Okay, then yes.
Explaining again why like the diagonal force takes more like because I was driving to particular like but like the distance of one to the pivot is shorter than
okay, because if your line is slanted, that means my line is made up of both horizontal and vertical force combined together to get the resultant line, right? So this is like the overall result. This is the resultant line. So for this resultant line, it is actually made up of a vertical force upwards and a horizontal force. So you imagine if maybe two of us, you pull vertically and I pull horizontally, we then can get the object move diagonally, correct? So that's why this force D, how much is the vertical force? Can you see it's smaller than C? Because remember for free body diagram, the length of the arrow is also the amount of force, Yeah, so that means the amount of force here is smaller. Then if your line is so low, you see the angle is so low, right? This is even worse because your vertical component is only like this. That means you're exerting more force horizontally. You see, the horizontal line so long, but this one, the vertical line so short. That's why this one, the vertical force is very little. Yeah. Then in this case, for this question, you are supposed to look at the perpendicular distance, So for the perpendicular distance, it would be, you can see that they are all pointing like kind of like upwards. Okay, so if we were to match the corresponding perpendicular distance, I color code it. So maybe for this, the perpendicular distance is this. If you want to try of using, because it's like usually our forces always perpendicular or horizontal, right? If you feel that your answer is this, then your perpendicular distance would be this. This is your perpendicular distance. Then if, okay, example, right? If you don't want to see in a vector way, just do purely moments way. If you look at this force over here, what is your perpendicular distance? Your perpendicular distance, it would be 90 degree from the pivot. Is my line 90 degree? Okay, sorry, I sit very sideways from the TV, so I cannot really gauge is my line 90 degrees. Okay, so I'm trying to draw the two pink color line to be 90 degree, okay? Yeah, so then if you go and look at the distance, it will still be shorter. Yeah, so only the blue one is the longest lah. Yeah. Then for B, to draw the perpendicular distance, you can, up to you, can either extend out the pivot or you extend out the force. So if I extend out the force, my perpendicular distance would be like something like that. If my line here is 90 degree. Yeah, so this would be the perpendicular distance. Yeah, so overall, the green one would be the longest line. Yeah. Okay, you see the pink one is only until here. Yeah, so the pink one is shorter. Yeah. Okay, so done for this question. Then let me see. Is there any more? Question 24. So question 24 over here is on moments. Come, let's share your answer. So remember, when they say principle of moments, that's how you present your answer. Clockwise equals anti-clockwise. Then you put it in. Then you solve. Should be okay lah. The top one just copy from notes. So I told you right, must memorize. So should be okay. Then for B, just submit in. Quite straightforward. Then over here, state and explain whether the moment due to the 6 Newton force increase, decrease, or remain the same as the lever hole puncher is pushed down. So they said that the answer is increase. Why? Because the perpendicular distance increases. Okay, so let me explain to you part C now. No worries, I will give you the answer key, okay? So even if you can't copy finish, you can still copy it at home. Okay, so for part C, they said that when the lever hole puncher is pushed down, so you see, if your lever hole puncher is pushed down, then they're asking you what happens to the moment. Okay, so let's take a look. So if your lever, okay, if your force is here, your, how to say, wait, let me think how to explain. The perpendicular distance, yeah. Okay, so, okay, let me do it this way. Okay, you know that this one is like the center of the circle. So this one is like by right, okay, if there's nothing blocking, it can keep going round and round and round. Something like this, like the, you know, the clock needle, right? Can visualize it? This is like the center of the dot is a clock. So that means, in other words, if I draw a super big circle, it should be something like that. So that means here, if you look at the perpendicular distance, this would be the perpendicular distance, correct? But when you press down here, can you see that the perpendicular distance is further? Can you see that it's a greater, like longer perpendicular distance? So that's why in this case, they mentioned that the perpendicular distance increase, although that's the reason. Can you all follow and copy this now so that you know what the answer key is saying? Because the answer key just say increase, but they never explain to you like how exactly it's increasing. It's because of this. From a perpendicular distance of this short line, it became a perpendicular distance of this long line. So the distance increased. Can you see that it's 90 degrees? Because your force is downwards. That's why perpendicular distance must be horizontal. So that horizontal is perpendicular to vertical. Okay? Find the which line? Wait. I realized I draw a bit wrongly. I should touch the pivot. Sorry, my pivot is here. So it should be like that. Is this what you're asking? Or this is still not what you're asking? Ah, ah. No, I'm trying to say that like this line is shorter than this line. For this line, if I extend it out, it's only until here. The bottom line is longer than the on top line. Because as mentioned, this hinge is like the center of the clock. This is like my clock middle ma. So as you keep going round and round, when you come to here, as a circle, this is longer distance. Or is that still not what you're asking? Or if you're not sure, you can stay back after class, or I can continue to further explain to you. Okay, so let's continue on. So so that's the answer. Okay. Okay, then I think, yep, let's continue on to the next part of the note. I haven't finished the chapter yet. Yeah, so next page would be the sentence writing. So first half is all the calculation. Second half is all the sentence writing. So for center of gravity, it would be the part where most weights are at. So take note, okay, that center of gravity, they will usually shift towards the weight, the part where there's more weight, towards the side that has more weight. Okay, so next part will be stability. So stability, you have three different types. This one, I think you all learn it in school. This one you all should know. So this one, no problem. I don't want to go through basic content anymore. I go through with you exam strategies, like how do you write your explanation answer. So keywords you need to have is 2 points. Number one, you need to always mention that like whether the line of action of the weight, is it within or outside base area? So that means like for example, if you have an object that is like, you know, sideways, and then what you do is your line of action on the weight. What is line of action on the weight? It refers to the weight line that you draw. So the line of action of the weight, whether is it within or outside the base area. So this would be the base area. So this is how you write whenever they ask you to explain. Okay, so explain, you write the first point. Then after you're done writing, then you say that, okay, so this time round, if it's still within, means it would be able to produce is it clockwise or anti-clockwise? You can tell, right, this object in the end, it would rotate this way. So that means it will result in an anti-clockwise moment about the pivot. So do you realize, be it open-ended calculation or sentence writing, do you realize it's always this phrasing? Must always take moments about which point. You take a look at the calculation just now. Over here, you see? It's always like that. Taking moments about the pivot. So this topic must always have this phrase, very important. Okay? This topic must always write down moments about which point for calculation and sentence writing. So you see, sentence writing also must mention moments about which point. So must always identify the pivot. Clear? And then factors affecting stability. This one I think you all should know lah. Okay, come, let's take a look at a question related to this page. MCQ question number 10. Can you flip to question number 10 now? The base area is when it were to touch like the ground, what's the width that it is touching the ground? So that's the base area. On the rectangle, so if your rectangle is like that, then your base area is here. But if your rectangle is standing like that, then your base area is here. Like that. Then you see, originally it's from where? Originally, is it from here? If it's from here, then it will be here. But if you are lifting up like that, then your base area is here. So you must see where the original position is. Okay, so answer is D. Because need to know, okay, whenever you suspend it, the line should pass through the pivot and the weight should be in a straight line. Yeah, so that's how you balance. Cause only when there is zero perpendicular distance, then moment would be zero. Because if you look at all other scenario, like for example, like maybe I look at this, you realize there is a perpendicular distance. If there's a perpendicular distance, means got moment. Yeah, so like over here also, you see, there is a perpendicular distance. Here also got a perpendicular distance. As long as you got perpendicular distance, means got moment. No perpendicular distance. Because you see, the pivot and the weight is all stuck together. If they are all stuck together, that means zero distance, no gap between them, right? So zero distance, zero moment. Because F times D is zero, moment is zero. Done. Okay lah, then let's take a look at the open-ended. Sorry, can you me to flip through the open-ended? Is there any like moments question? No more, I went through that one question, right? Okay, then no more. Yes. Uniform thickness versus uniform density. Actually, both means the same thing. It's more similar lah. If as long as it's made of the same material, same thickness means same density. To the question itself. You mean here?
Doesn't that affect if like the bigger side and the smaller side have the same weight, or they have different weight?
Yeah, if they have different density, then the center of gravity won't be at this point X anymore. It will shift towards the side where there is more weight.
Yeah, the bigger side and the smaller side have the same weight.
Not really. It's a bit off to the left side. It's not exactly the center. What you measure from left to right, it's a bit towards the left a bit. It's not exactly the center. Yes, it does, because the bigger the size, the heavier it is, ma. For example, a fat man, bigger size, also greater weight. Yeah, so bigger size always greater weight. Yeah, so the CG will always go towards the side where more weight is at. Yeah. Okay, so done for this part here. Then let's move on to lens. Okay, so for lens over here. Okay, so for the front part on reflection and refraction, I'll leave it to you to go and read through on your own, then you study it on your own. My focus would be on lens. Can you all flip to this page over here? Page 25. Oh, that's a good job. You can if you are not tested, then why not you try to do more of the mock exam, because I'm going to go through the answer later. Okay, so for lens over here, okay, of course your school teach you the table, right? But teaching you the table is very the standard way of teaching. Usually at tuition, I will change the way that I teach lah. So this is the way that I will teach. So first thing you need to know that for ray diagram, the rule is you must always draw in the compulsory line. So take note, okay, for ray diagram, you will always have a compulsory line that is a straight line that actually connect from where to where? They will connect from the object to the optical center and the image. That means, in other words, if I have a question that says like that, I have an object and then I have an image. Can you locate where is the lens? So to locate where's the lens, you always draw this straight line that connect these 3 points. So you see, I connect from the object to the image. So once I connect from the object to the image, this location here would be where your lens is at. Yeah, so just remember, okay, that first line, always draw this line. The second line that you draw will then be this. So this is the second line to draw, where it is always horizontal become diagonal, or diagonal become horizontal. But take note that the diagonal line must always cut through point F. So over here, what I mean is, okay, if I refer to the typical diagram that always school notes show you, like this one, right? So that's what I'm trying to say. Horizontal line must always become diagonal and cut through F. Or if it's a diagonal line cutting through F, it must become horizontal. So it's either way. Horizontal become diagonal or diagonal become horizontal. Okay, then next would be, you need to know that for object and image, they actually move in the same direction. That means if my object moves to the right, my image will also move to the right. But when they move, they might move different amount. Okay, so that's how object and image is. This is the kind of question, right, where they like to ask you, for example, I have a lens. Then, I shine my light. Then in the end, when the light meets, wow, they overcross, then my screen is over here. Then they ask you, like, what you can do, like, what, shift the lens or shift the object or shift the screen and stuff. So take note, if you want your image to go to the right, that means your object should go to the right because they move in the same direction, just that it's different distance. Yeah? So you can also see from over here, the typical diagram. This one, you already know it. Yeah. So you see for the object, when it's like over here, when it's like so far from 2F, and now you move to the right. So once you move to the right to be at 2F, can you see that your object, which is from between F and 2F, like here, they also shift to the right. So you see, object and image shift in the same direction. You look at the next one. From 2F, they shift in to be between F and 2F. And now what happened to my image? They will also shift. So can you see that both object and image, they will shift in the same direction? Okay, so that's how you can know how to make an object to be focused. The next tip that I have over here is that whenever they say inverted, do you realize over here got a lot of inverted, you see? Inverted, inverted, inverted. So whenever they say inverted, what does it mean? It's not only the vertically inverted, the up and down. It's also laterally inverted. That means left, right, flip. So it's double inverted. So take note, the inverted refers to both vertically and laterally inverted. It's just that you can't see that it's laterally because arrow is symmetrical. You flip left and right, it still looks the same. But in real life, it will actually be laterally inverted. Next, this is a very, very favorite question, right? I think you all answered this kind of question before. When they cover the bottom half of the lens, what happened? I need to know that you can still form the image, just that it's dimmer because light cannot pass through the bottom half. And then when object move closer to the lens, you need to know what happened for magnifying glass and the rest. I think you all know, right? Like how to use magnifying glass. You need to hold the magnifying glass at a distance away from like your paper, right? And then you can be magnified, ma. So if you bring your object closer to the lens, so that means my lens and object closer. If I put my magnifying glass on the paper itself, isn't it like it's not really magnified? Yeah, so that's why when it is like too close, it will be less magnified. So then take note, for other scenario, it will be opposite. Why? Because the properties are also opposite. Do you realize? For magnifying glass, it would be the upright virtual. Then the rest are all inverted real. So inverted is always with real. Then upright is always with virtual. So since it is totally opposite for the rest, that's why the effect will also be opposite. So for magnifying glass, if it's less magnified, the rest will be more magnified instead. Which you can see also. See, when you move closer, let's take a look. We look at this tree. When you move closer, can you see the object from more than 2F now become 2F, less than 2F? So you see, as you move closer and closer, what happened? From diminished, same size, magnified. So it gets bigger and bigger. Okay, then yep. Then next would be the drawing of light ray. So just now I mentioned to you, right, the horizontal should become diagonal cut through F. But question always like to ask you some weird angles, right? Like this kind. If I point at the middle of nowhere, not cutting through F, not cutting through the center, not horizontal. Then this kind of lines, how do you draw? So the so-called non-horizontal lines, they always meet at the focal plane. Focal plane means that this point F over here, plane means the layer. So the layer where there is the point F. Yeah, then they will all meet over there. So how do you do such question? You refer to your first scenario over here. Because parallel lines always refers to object that is super, super far away, like maybe the star or the moon or any other planet. So for parallel line, do you realize, you see, they all intersect at the focal plane. That's why for this question, this is one of the favorite questions that school like to test because it's like students always answer it wrongly. So what you need to do is follow my guidance. I say that step 1, always draw the compulsory light ray, right? Which is the straight line. So now what you do is you take your ruler. You know your ruler, you can like, one ruler here, then another ruler here. You can actually like, slide your ruler, right? You slide up to form the parallel line, correct? You know how to do the parallel line, right? So you slide up such that it cuts through the center. Because you must always draw in the compulsory line. So I'll label this. Hello, can you follow and write it down? Always draw in the compulsory line. Write it in. So you slide it up such that it's parallel and then cut through the center to get the parallel line. And I mentioned, right, all the lines must intersect at the focal plane. So that's why step 1, you draw the compulsory line. Step 2, you locate where is the point where the compulsory line and your focal plane intersect. Yep, so that's why I will see where this light ray and my focal plane intersect. So once they intersect, all the light will just meet at this point of intersection. Hence, so you see the rest just meet. Because I mentioned all of them must meet and intersect at the point of intersection. Yeah? Yeah, so that's how you draw it. Yeah, so what I've just mentioned to you is also written in text over here. Yeah, they all meet at the focal plane when object is like from infinity, which is parallel lines. Okay, so then done with that. This one you all learn it in the notes, so I don't want to go through this anymore. Okay, so let's take a look at questions that has lengths from the worksheet. So it should be, let me see, question number 18 and 19 of the MCQ. Over here. Then you see, ta-da! Again, when you have parallel lines, isn't this light ray from infinite? And we see that all of them must meet at the focal plane. So if they were to intersect here, that means this is the focal plane. Do you agree? Right? Because we mentioned that all the light ray will meet at the focal plane. And since they're asking you, where will all pass through? Remember, the rule is horizontal line must always become diagonal line and cut through point F. So this is your point F. That's why horizontal will become diagonal and cut through point F. That's why the answer is C. Okay, then question number 19, here's the answer. Remember, I told you object and image, they will move together. Since this time round, the screen is too early. Because by right, my line is like, by the time they intersect, my image is somewhere behind. So that means I need to shift my image to the left. So how to shift the image to the left? You shift the object to the left, because image and object move in the same direction. Okay, then done, right? Okay. Anyways, any questions? Okay, so I just go through a little bit lah. For B, C, D, Y are not correct. Okay, so for B, they say use a longer focal length. So you need to know that if you have a longer focal length, what happens is, okay, for example, if it's a horizontal line, if you have a short focal length, it will bend more. If you have a longer focal length, it will bend less. That means, in other words, if you have a longer focal length, the result is they will refract less. So if they refract less, isn't it worse? It will be like that. So maybe by the time they meet, it's like, I don't know where's, yeah. Yeah, so that's why this one incorrect. Because by the time they meet, you'll be even further away. So this is incorrect because you should say shorter focal length. You need them to bend more so that they can meet earlier. Then for option C, move the screen towards the lens. As mentioned, the screen is too near already. You should move the screen away. So that's why it should be away. Next, use a brighter. Brighter only affects brightness. It doesn't affect the sharpness. Hence, so I write down over here, affect brightness, not sharpness. Yeah, like that. Done. So are you all done with all the annotations? I told you, all these annotations is not in the answer key, so you need to write it down. Oh, okay, can. So what about 18 that you are unsure? You ask me instead.
I'm not sure how it's going to see because I don't only the ray that goes through the middle will go through the focal length.
It is the light ray that goes through the, okay, I try to draw parallel. Then if it's the light ray that goes through the center, it won't pass through F also.
Oh.
Then for the horizontal line, it would be linked to this part. We always say that whenever it's horizontal, it should become diagonal and cut through F. Horizontal become diagonal, cut through F. That's why horizontal should become diagonal and cut through F. And do you know why is this focal point? This is the focal point is because for parallel light rays, they all intersect at the focal plane. Over here also. Parallel light rays, they will all intersect at the focal plane. So that's why they will all intersect. Can you see the lines? They are all intersecting at the focal plane. That means this is the focal point. Yeah? Okay. Then next, let's take a look at question 27. Over here. So this is the answer. You can check. Okay, so how do you draw it? So mainly is remember the compulsory light ray. So for the compulsory light ray, it would be first, you always draw from the object to the center to the image, correct? So that's why you see, once you connect from the object to the image, then you will know where the lens is really long, right? Okay, then hmm. Okay, then next would be wait, let me read the question. For part A, they are asking you to draw a suitable ray diagram to locate the position of the image. Okay, so in this case, you just need to draw the usual light ray because you always draw the compulsory light ray. Okay, let's see the question. Okay. Yes, okay, okay, thank you. Okay, so in this case, you just draw through the center, you extend it out. Then you know that since they did draw out this line for you, right? That means they are trying to say that your image is over here. That means if your object is straight vertical, your image should also be straight and vertical, ma. Yeah, so that's why once you draw this line, then you just draw a straight and vertical line. The place that they intersect, this would be the height of your image. Can understand? So that means you just draw out this line. And since we know that the object is vertical, that means my image will be vertical, just that I do not know how tall. But how tall? It is the height of where the point of intersection is. So done. So this would be how you draw the image. Okay, then next would be what's the next part? The next part says that by drawing another ray from point B, mark the focal length. Yeah, so how to draw the focal length? Remember, it's always the same rule. The horizontal become diagonal line and cut through point F. So the diagonal line, since this is from arrowhead, that means this horizontal line must end up at the arrowhead. So that's why from here, you must reach the arrowhead. And once you reach the arrowhead, the part where they cut through the principal axis, this would be the focal length. So take note, focal point is capital letter F. But focal length, it would be small letter f. Do you see the difference? Caps versus small letter. Okay, length is small letter. Point is capital letter. Yeah, so this is the focal point. Okay, then I shall move on. Done copying, right? Okay, then next would be part C over here. The converging lens may be used to form a virtual image of the object AB. State where the object is placed relative to the lens for a virtual image to be formed. So they are asking you like where do you place the object to be virtual. Then this one just check notes, right? This is the magnifying glass scenario, right? You put it less than F lah. This one should be okay lah. Just checking notes. Next one. Then favorite question again, lor. You cover top half or bottom half, then you'll know what the answer is lah. Done. Yep, so that's all for lens. Okay, then we shall now go through all remaining answers then. Yep, so no worries. If you're not done with correction, I'll give the answer key. Okay, you can slowly copy down your correction. Okay, I shall show the MCQ answer now. Okay, so can you all check your answer? I'll show first 10 first. If you haven't do this mock exam paper, I'll recommend that why not you shape the OAS sheet. Then you know later when you do it in the question paper, you can come back to the OAS sheet to check if your answers are correct. Yep, so you'll share your answers. Sorry, I just saw Gwen's question. Gwen is asking, how do you know? Oh, I remember you. Yeah, you were changing from the pure to IP physics, right? You were saying, how to know if the ray R is parallel to principal axis? Wait, which ray R are you talking about? You mean the open-ended one, is it? The one that I just went through, is it? Okay, okay. Sorry, I go to question 18 first. So for question number 18 here, ray R. Oh, this one. Okay. How, how do you know it is parallel to the principal axis? By I power, this is parallel? Is that what you're trying to ask? This looks parallel. It doesn't look parallel to you? You can use your ruler to slide off. If you slide already, then it's parallel, then yeah, it's parallel. If it's not parallel, they will draw like that, like very obvious one. It's like not parallel to the principal axis. They won't be like with uncertainty kind. Yeah. It's not a skilled diagram. It is you do not need to measure the angles or measure the cm. Because skilled diagram means you measure the cm and the angle ma. So in this case, it's just use parallel, just two ruler, just slide to get parallel like this. Yeah. Okay. Okay, people. Yep. So done with question 1 to 10. I move on. Okay, so moving on to the next half. Here's the answer. Check your answers. So I give you another 5 more seconds. I shall move on. I should be almost done checking by now. 5, 4. Okay, I give you a more. It seems like you are still checking your answer. You should write it in front so that you can attempt the question. You better write answer, then how you attempt next year. That's why I say that if you never do the paper, you shade the OS sheet instead. So that you have a clean, blank worksheet, then you can do it. Yeah. Okay, so should be done by now. Okay, so I shall start to go through the MCQ now. We go through page by page, okay? So starting off with the first page. Anyone need me to go through any question from the first page? Which is only left question 1. So don't need go through, right? If need, must tell me. If not, I already move on. Okay, moving on to the next page. This page, I went through just now, right? Okay, then we move on. This page over here, did I go through just now? I also went through. Okay, then we move on. Question 10, this page. Did I go through the whole page? No, the below I haven't go through. Anyone need me go through 11? Yeah. Someone said something online. Can you repeat? Did someone say something? Because I didn't catch. Anyone need me to explain question 11? Okay, can. I'll go through now. Okay, so for question 11 over here, take note, this number here is a trick number. You should ignore. Okay, so what you need to do is, for pressure, you always go by, like forces like that, right? Upward force equals downward force. So you go by upward pressure equals downward pressure. So in this case, since you're exposed to the surrounding air, that means there will be downward atmospheric pressure. Mercury is very dense, right? So it has its weight and all, then of course it will have a downward pressure. Mercury in periodic table is letter Hg, okay? So I write Hg. Then the air, obviously they are trying to escape. So the air is trying to get out. So air, it should be upwards. That's why you classify them accordingly. Which one point up and which one point down. Then you sub in the values. So since you're supposed to calculate the pressure of trapped air, you're not supposed to use this. You're supposed to go and calculate it. Yeah, so that's why trapped air is, you just add up these two. Yeah. Then take note, okay, whenever, okay, take note, okay, people, listen up, this is important. Whenever it's a pressure question, if they were to give you the units in terms of cmHg, you just need to simply plus minus the length will do. So that's why you see, I just plus minus the cm will do. There is no need to use formula. Don't go and try what rho gh and stuff. No, don't do that. Only if question is in the SI unit of Pascal, you then need to use the formula of the P equals to the rho GH. Clear? So take note, only in SI unit, you then use formula. In CMHG, don't need to use formula. Okay, then after this question, I will move on. Done copying, right? Okay, so I'm moving on in 3 seconds. 3, 2, 1. Moving on. By the way, if you find that I'm too fast or what, then you want the annotation, you can also take a photo or take a screenshot. So moving on to the next page. Question 12, this page. Any question to go through? You need to go through any of it? Don't need, Okay, good. That you got it right. Moving on, next page. Question 14, this page. Need me to go through any of the question? Which one? 14 itself. Okay, can. The rest need to go through? 13. Okay, I'll go back to 13 first. Okay, so for question number 13 over here, they have two objects that is exactly the same. They drop at the same height into two tubes. And they are asking you which one is correct. So for Neha, which option do you choose? You choose A. The kinetic store of ball A is greater than B because it falls through a greater vertical distance. Okay, so by the way, do you still remember for kinetic store, what is the formula? What's the formula? Correct, half mv squared. But here you see is distance. Is distance in the formula? It's not in the formula, what? Yeah. And anyway, vertical distance is not greater. The vertical is like that, right? Vertical is straight, right? It's the same, so it's the same. Yeah, so that's why I cannot. Okay, then for question number 14, I told you at the start of the lesson there's an error, right? So make sure you cancel the word rate off. Okay, so they said that you have a tiny boat that is original at rest. That means the U is 0 and reach a speed V of 1.5 and T is 10 seconds. And the water resistance is 2. So they are asking you what's the work done against water resistance. Just to let you know, work done against resistance is actually just work done of the air resistance. Sorry, of the water resistance. That means work done is F times D. So F is just the water resistance force times the distance that the water resistance act on. So work done against is just work done off. The reason is because water resistance always go against your motion, right? That's why they use the grammar word called against lah. Yeah, but actually it just means what is the work done of water resistance. Yeah, that's why you calculate everything in terms of water resistance. So in order to have your F and D, let's check, do we have the value? F, I have it, very good. But D, I don't have it. So since D, you don't have it, then you have to go and calculate the D off with the initial speed, final speed, and time. So there are two methods. You can either go by the area under VT graph, cause initially rest till a speed of 1.5. So you can go and find out what is the area under the VT graph. That's one way. Or you can use the equations of motion, S equals half U plus VT. Then you just submit the value for both of them, you can still get the answer of 7.5. That's how you get the answer of D. Then once you sub it in, you multiply, that would be the answer. Okay? Yep, so if you got it wrong, make sure you copy down the working. Okay, then likewise, I'm going to move on in 3 seconds. If you're not done, maybe I'll take like a screenshot or a photo. If not, you try to memorize it. Okay, so I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. 15, you all said don't need, right? Okay, then I'll move on to this page. Anyone need me to go through this page? 16, sure. Okay, so for question number 16, for reflection topic for upper sec, right? The favorite question that they like to ask is you either use trigo like sine, cosine, tangent, or you need to use similar triangles. Okay, so right, okay, let me just roughly draw. Okay, so maybe like that, bounce up, something like that, okay? I know my drawing not accurate. Okay, but do you see the similar triangle? This and this is similar. The hypotenuse and hypotenuse is similar. The base and the base is similar. Do you see the triangle and the triangle? Yeah, so then you use the similar triangle method. You all learned math before, right? You know how to do it, right? Yeah, just like that. Then that's why they want you to find this part here from A to the point of incidence. That means find this length over here, which is X. There is no need to prove similarity because based on the light, because of angle I equals to angle R, the triangles will definitely be similar, right? How you see? If I join the normal, the angle I and angle R will be the same. So if the angles are the same, they are definitely similar triangles. Does that answer Zane's question? Okay, so should be done with the correction. Okay, then we move on. So for this page, yours, did anyone need me to go through 17? Yes, okay, can, I'll go through. First, people, is this the angle of incidence? This theta. No, right? Because angle of incidence must always be between the ray and the normal. So this is then the angle of incidence. Okay? Have you all labeled? I'll label it in. Okay, then on the next part over here, so the theta, as I told you, theta is not the angle of incidence. So if the theta is 30, what's my angle of incidence? Hello, theta is 30. I should be how much? You look at the diagram above. How much is, correct. Yep, 60 degree. Then continue on. If theta is 0, my I is how much? We look at the above angle. If your theta became 0, what's my angle of incidence? My angle of incidence is 90, right? Okay, so in this case, they are asking you to describe what's critical angle. Then remember, critical angle is the point where the light will travel along the glass air boundary. Then if you go beyond, if the light I shine in is bigger than critical angle, that means a super big angle, then obviously TIR. So over here, based on the brightness of the refracted ray, where did TIR happen? Is it before 30 where there's no light or after 30 where there's light? Do you know where is TIR happening, like total internal reflection? Before 30 or after 30? When does total internal reflection happen? Before, correct. Because here, no refracted ray. Isn't no refracted ray means like that? This is total internal reflection, right? Do you realize? There is no refracted ray, zero brightness. So no refraction means TIR lor. Can you follow and copy in? No refraction, right? Then no refraction means total internal reflection. So only when it reaches 30 or angle of incidence is 60, then it is total internal reflection happening. That's why critical angle is 60 lor. Can understand this part? Because only when your angle is 60 onwards, then you will have TIR. Right? Because remember, your total internal reflection over here, the angle I has to be bigger than critical angle. So only when it's bigger than 60, you see from 60 to 90, TIR happens. That's why it's 60 onwards. It is bigger than, that means 60 onwards, I is bigger than C. That means C is at 60 lor. Done. Next, refractive index, you sub in the C value, 60, to get 1.2. Yeah, so you can copy down the working for this. For Zane, total internal reflection is under the section where refraction is. So if your school got teach you refraction, then your school will cover total internal reflection. But if your school don't cover refraction, then you can skip total internal reflection. Yeah, so it's a concept, like something like moments. Like you asking me what is moments. So what is total internal reflection? Is the whole is a whole chapter of concept. Yeah. So total internal reflection is where they reflect on the inside of the glass prism. Okay, so I shall move on. Should be done copying the correction, right? If not done, you take a screenshot. Moving on in 3 seconds. 3, 2, 1. Okay, moving on. Then this page I went through already. Open-ended. So for open-ended, question 21, I went through already, right? 22, I also went through. 23, I also went through, right? 24, I also went through already. 25. Let's check your answer. Hello, 25. Check your answer for question 25.
I don't think that it did have something.
Okay, so I shall explain for part A first. So for part A, determine the pressure at point P over here. They need to know, okay, that whenever it's pressure is always things pressing down on us from on top. Something like, if your parent really keep pressurizing you, your end of year, last time must get A1, must get A, or must get 4.0. So isn't pressure coming from a generation above you? So pressure is always things pressing down on you from above. That's why for the pressure at P, it would be the amount of pressure from on top. That's why in this case, how much is this cut here? You take 1 minus 0.24 minus 0.3. This would be here. So this cut here is actually this blue color arrow. Then just use the formula, rho GH. Done. Next part. Suggest why the space above the mercury column in barometer B is bigger. Why bigger? Because got trapped air inside. Done. Part C, when they double the diameter, what happened to the height? So take note, okay, that height is related to pressure, right? Then height. So height is related to pressure. So now you check, if your barometer diameter times 2, did the pressure change? The pressure didn't change, right? So if your pressure no change, that means your everything else won't change. Yeah, so only when pressure change, the height then will change. So that's why in this case, the answer is unchanged.
Did you know?
Okay, due to time constraint, I shall move on. If you're not done with correction, later, as mentioned, I will send you the answer key. You can slowly and copy down the correction. Okay, so I shall move on first. Okay, then the next part over here, here's the answer, you can check. So total energy will include everything. And surprise, take note, for work done against friction is a plus. So I emphasize something, can you listen up very carefully? In the topic of forces, which is dynamics, whenever we have friction, what do? We always minus friction, correct? But take note, okay, under the topic of energy, we will always plus the work done against friction. Why? The reason is because force is actually a scalar quantity. Sorry, force is a vector quantity. Since friction is always in the opposite direction, that's why we use minus sign. But energy is a scalar quantity. And you imagine, if I ask you push a box on a smooth surface versus I push a box on a rough surface. If I push on a rough surface that got friction, isn't it more tiring? Maybe I got muscle ache and stuff. Yeah, so you need more energy to push, right? You need to do more work if got friction. That's why it should be a plus sign. Yeah, because you need to do more work when there is friction. Okay, so take note that in energy topic, you plus friction, you don't minus friction. Yeah? Yep, then that you just sub in the values, I think should be okay lah. Then final answer, can you check? Do you have the units? Include the units for the final answer.
And then from B to 3, it'll be KD plus equals to GP of G.
Okay, so anyone need me to explain to you in detail like how to get each number one by one? You can understand what the number means, right? Can If need me to explain, you let me know, okay? Okay, so I shall move on already. If you're not done, you can either take a photo or screenshot or you wait for the answer key also can. So I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. This one I went through now. Oh, I'm done. Yay! Nice. Yay. Well, not bad. We shot quite fast. I finished 4. I'm finished more than expected. That's good. Okay, so right, about the answer key, right? Maybe is it possible to get you all to help to scan this QR code and give us a feedback? Yeah, so just to let you all know, Overmark, we actually been conducting this free end of year revision every year. Yeah, so if you want to join us next year also, yeah, you can also follow us on like IG or TikTok or Telegram. Yeah, so give us the feedback so that we can know how to improve it for next year. So like last year we received feedback that like our lesson was 2 hours. A lot of people find that it's very short. So this year we extend it to 3 hours. Yeah, so can you all scan and let us know your feedback? Yeah, so you see, like we spend so much time and effort to prepare the material, distribute to you all at MRT station. You see, we spend time during lesson to go through with you. Yeah, so can I spare just 1 minute of your time to fill in the form? Yeah, if you're appreciative of our like efforts. Thank you. Then once you're done filling in, you let me know. Then I can give you this very cute footstep. And our footstep is good quality one, okay? It's A-zone quality. It's a thick one. Yeah, you can get a few of it. Yeah. So if you are done filling, then I'll give it to you. For online attendees, I'm very sorry that like I can't give it to you because you're online. So like I would still appreciate if you can help to fill in the survey form. Then if any of you like want the full step pad, then you try to see whether is there any more like physical slots to attend. I try to attend physical lessons lah. Then you can get to receive the full step pad. Yeah, but I know also limited capacity lah. Not everyone can get. So it's like first come first serve. Whoever who can get first, like Taylor Swift ticket like that. Yeah, then who can get the physical ticket first can attend physically. So if any of you later you all have any like questions related to physics that you want to clarify with me, feel free to stay back. I can still answer your question after lesson. Okay? For all why you're asking why friction on the left side instead of the right side. Oh, which question are you at? Okay, thank you for filling in. So once you are done filling in, you let me know. I can give you the first step. Question 26. Okay, let me go back to question 26. 26. I will be showing the answer key soon after they are done with the survey form. Thank you. Take it, you. For question 26, this one, then you are asking about why friction, 26, friction. The friction direction doesn't matter because energy is scalar. You're saying like why right on the left? Okay, I explain to you after class. Okay, yeah. Okay, then anyone else done so that I can give you the second? Can I take a look at your phone? Thank you for making it so complicated. Thank you. People, don't leave yet. I haven't showed the answer key yet. Yeah, I settled one by one, sorry. I cannot multitask. So,
in the leadership day we have because so much there was so many leaders in the class. It's like it's like there's like this transition so like 12 people get fun on the floor going like transition and then they just like they will say so
okay, so then so here's the answer. Oh yeah, oh wait, before I'm showing you the answer, just wanted to let you know that we are here if you need more help. Like if you find that the lesson today like only go through a few topics, like not enough, right? So if you need more help, we are here to be able to help you. So if you're interested, we actually have like booster class, just mainly to help you for the last lab lah, before the end of your exam. Yep, so if you're interested, here are the details. Yep. So then if you have any questions regarding like the regular tuition, you can also stay back after class. I will be happy to answer your questions. Okay, so sorry, what did Zane say? Okay, so here's the answer for the mock exam paper. Wait, wrong level. Okay, this one. Yeah, okay, this is the one. Yes. Okay, yep, so that's all for today. So hope the lesson today has benefited you and hopefully it's like clearer in terms of concept and you'll manage to pick up some skills that like schools didn't teach you. Yeah, so that will be all for today. So if you're attending any other like free lesson, so today is the first session. If you're attending any other lesson, remember to finish your mock exam paper before you attend the lesson. Because you can see, right, if you finish your mock exam, you come for class, it's more beneficial for you. Then if any of you are interested to attend the IP chemistry class, but then you never collect the booklet, you can stay back, I can give it to you. Yeah, so I still have some more IP chemistry booklets. So yeah, that's all for today. You can pay and go already there. Bye-bye. Yeah, so any of you have any question, you can stay back, I can answer your question now. Alright, I will answer you. Give me 1 minute. Yeah. What do you want to ask? Yeah, you ask the answer.
because we have the physics, we have a physics show and tell, so we have to use a toy to show and tell like physics concepts. Do you think a Rubik's Cube will be a good idea? What's like a Rubik's Cube? Like, does it demonstrate physics concepts?
What physics concept are you trying to demonstrate?
Like the
I can't think of it.
rotation.
Not really, yeah. Thank you for filling in. Thank you.
I was going to collect my bio, Sep bio thing.
Can I can pass it to you today. This
one of Monday, then there's one of Friday.
no, that's next week. Maybe the actual September holiday. Like next week. So next week will be double lesson. Yeah. Yes.
Like for this displacement time graph. Like, how do you know if it's like how do you know that the velocity is in it?
How to know if velocity?
It's not like you at a equation.
So meaning, okay, wait, I try to draw on the screen. So that means you are saying that you have a graph like that. Is it for displacement time graph?
Yeah.
Okay, then you are saying,
Like how do you know it's like straight up, like the velocity?
oh, because gradient of a displacement time graph tells you the velocity, right? And the gradient is from gentle, it becomes very steep. That means the gradient increases. So if gradient increase means speed increase. So then when you draw the speed time graph, this is positive, okay, so plus positive. That's why you draw it go up. Because you do not know whether it will curve or not. To know whether it curves, you need information on the acceleration. But in a displacement time graph, I never give you any information on acceleration. It's a bit too far. Because you know I had this arrow thing. From displacement, I can only tell the speed. But I can't tell the acceleration. Yeah, so at max, I only know it increased. But how is it increasing at what rate, that kind, not possible to tell.
Oh, so it's like an assumption.
Yeah, we'll just draw the simple version. We won't, because if you draw increasing at increasing rate, then why cannot draw increasing at decreasing rate? Right. So it can be increasing rate or decreasing rate, ma. Yeah.
Oh, okay. Thank you.
Yeah, no problem. Oh, yeah, okay. Thank you for filling in. Okay, so let me take a look at the questions for those of you online. Wait, I go through one by one first. I start off with the just now alright asking me a question, right? Let me change it back to the escape. My mock paper is this. Okay, so just now you were asking whether why the work done against friction, you put it on the left side of the equation, correct? That's the question, right? Okay, so let me go through it with you. The reason is because it's about the energy at the start versus the energy at the end. So for the energy at the start, it would be at this position A here. So at the start, it would be the energy at A, where it is you have a certain height and there is a speed. That means you have both the GPE and KE. You have both gravitational potential store and kinetic store. That's why the formula can tell, right? This is the kinetic energy. Let me maybe label it clearly for you. And this is gravitational potential store. Okay, then this is I would say the energy at the end. Here it would be the sorry, at the start. Then here is the energy at the end. Yeah, so the energy at the end, you need to know that because you keep rubbing the whole surface until a lot of heat, right? So that's why towards the back, there will be a lot of work done against friction in the form of like internal store, like thermal energy. Yeah, so that's why towards the end, there is the work done against friction, plus it goes a certain height. That's why there's the gravitational potential store. So does that answer your question for all right? All good for all right? Can? If okay, then I move on to the next person. Can okay. Then let me continue look at the list. No worries, I'll answer all of your questions. Okay, just let me scroll down the list. So after all right question was all right is also asking for the answering technique for the line of action of its weight within its base area, that one. What is this applicable for? Oh, so it's about whether they will ask you, does the object topple? Then they ask you to explain your answer, then you can use that. Yeah, or like which yeah, so many is about whether the object topple. That's all. Okay, then next is let me scroll down. Then Gavin is saying, can I sign up for the permanent class for IP physics even though you are mainstream? Why you don't want to attend the mainstream class for Gavin? Is there any reason? Because OVERMUGGED, we have mainstream express class. Okay, then I continue scroll down. Let me see. For Nick, you're asking how does refraction work? Can I just check, like, have your school started teaching you on refraction? Because by right, for IP students, you're covered refraction even from lower school. So lower sec. Yeah, so now you're already in upper sec. By right, you should know. Like, I'm like a bit puzzled. Like, why you're not sure how refraction works? Okay, then I continue scroll down the chat. Gavin, oh, I saw another message from Gavin. Sorry, in between got a lot of other messages. So Gavin says, am I allowed to attend IP science class permanently as a mainstream express triple pure science student? Can, because this is tuition, it's not school. Yeah, so you are allowed to attend IP class. But take note that the main difference between IP versus express is, okay, number one, of course, the content, the depth is greater. And number two, we are slower. Because IP don't need to take O levels. Yeah, so they teach very, very slowly. So you realize, you see, for like today's lesson, we don't even cover thermal. But express schools actually do cover thermal and quite a lot of wave themes. Yeah, but for like, maybe for example, like my class, like my NYGH class, they only finish like mechanics and light. That's all. The general wave properties, EN, spectrum, sound, all this all not covered yet. Thermal energy also not covered yet. Yeah, then like maybe for my RGS class, we covered like all the mechanics topic, plus general wave properties, EN spectrum, and light. But also haven't covered sound, haven't covered thermal yet. Yeah, so generally IP classes tend to be very slow. Yeah, and that yeah, I would say so that means mainly the depth and the speed differs. Yeah, so if you want to sign up for IP, yes, it is possible. Okay, then moving on to Nick Her's question, what is the displacement time graph if the acceleration time graphs look like this? Okay, sure, you can draw it on the screen. Okay, then, okay, yeah, I think I cleared all the list already. Yeah, so I shall wait for Nick Her to draw it out. Okay, so it is like that. Then you will have to do section by section. So from an AT graph, you can't immediately jump to a VT graph. Yeah, the reason is because AT, you can only link it to VT. So you have to draw a VT graph first, then link to displacement time graph. So all exam question, they're impossible to ask you, from this AT graph, you draw a displacement time graph. No, they won't be able to ask you that way. At most, they only ask you VT graph. Yeah, but out of learning, sure, I can go through with you. Okay, so for a VT graph, okay, so first is you have to take a look at the acceleration to see how it is. So if there is zero acceleration over here, a equals to 0. So the okay, need to see the question. So like, is my object at the start moving or not moving? So if my object is at rest, I can draw over here on the start line. Or I can draw over here. Because you see, if I draw over here, my object is still not accelerating because I'm traveling at constant speed. Yeah, so either one of them could be the possible answer. Then on the next part here, if you're accelerating, means that your speed should increase. Yeah, so that's why for the speed over here, it should increase. And then the increasing line, is it a curved line or is it a straight line? The answer is straight line because the gradient of a VT graph tells you the acceleration. And if you look at the gradient at the start and at the end is same steepness and that the line is slanting upwards. So upwards isn't it positive gradient? That's why you see it's constant at the number 1 and the number 1 is positive. Okay, then next part over here, this likely it should be, I don't think it will suddenly break and come to a stop. So I'll take it that it will just travel at a constant speed for this part here. Okay, let me include the timing. 3. This one is 6. Yep, so over here, if you are not accelerating, likewise, not accelerating means you are driving at a constant speed. Then here is deceleration because it's negative. So that means you are slowing down. So when you're slowing down, and this is a bigger value, right, to 4. Here only to 1. That's why here when you slow down, your line slant down more. Can you see that my line is steeper than earlier on? Yeah, because there is a greater deceleration. So in this case, your line is still a straight line because similar to just now, that is constant. So over here, the gradient of a VT graph tells you the acceleration. And the acceleration is negative and constant at -4. So constant and negative. That's why you see, remember I told you, right? Upward is positive gradient, downward is negative gradient. Yeah, so this is the negative gradient. Then you come down 6 to 8, right? So this would be 8 log. Done. So this would be the answer for VD graph. Then after VD graph, you then convert to displacement time graph. So need to do another step. Okay, so it is displacement time graph. Okay, so I shall bring on the on top. Okay, so for this on top line over here, displacement time graph. So if your speed is constant, remember gradient of a displacement time graph give you the velocity. How is my velocity? My velocity is constant. So that means when I draw this, I should draw a constant gradient. So it should be straight line up. Because as you are moving, I will be moving further and further away from the start point. So, okay, yeah, so don't need further elaborate. Okay, okay. Anyone else have any other question? If not, I will end off the Zoom meeting already. All good? If no more question, then you can leave already then. Yep, that's all for today. Bye-bye.